about 80% completion. And if you don't have tests, after that point, it's like anytime you try to make a change, it's just so likely to regress in some other way that whatever you do, you kind of can't make forward progress. And I feel like that's where we've gotten with X11. We can't make forward progress, and if we change anything, we're gonna we'll fix some things and break other things, and we're not really gonna get anywhere. So we're kind of afraid to change anything. And arguably, we do have tests in that we have the user32 tests, but those tests have to run on Windows. So there's a certain class of things that we can't test because it depends on something that happens. For example, if the window manager decides to minimize a window, that works a little bit differently from a Windows program deciding to minimize a window. And when we have bugs that depend on something that happens in X11, or we have something that looks fine on the Wine side in Win32, but on the X11 side, it's not actually there. Like, for example, you might try to restore a window to a full screen mode, and in Windows, it looks like it's full screen to the Windows application, but the X11 window is not full screen. And I think we should be adding tests for bugs like that. A lot of the gaps that we have from not having those tests falls right now on QA at Codeweavers and at other companies that do QA on some wine-based products. So I don't want to just say we should do this thing and then not give any idea of how to do it. So one thought that I had was that we could add some sort of wine-specific API functions to X11 driver that are solely for the tests. So we do have wine-specific APIs in X11 already. We have ext escape functions, which are, I think ext escape only operates on an HDC, so we might have to find something else. Maybe special window messengers are a possibility. I don't know exactly. But I think we can then have tests that do things and check things on the X11 side so we can verify a lot more problems. And actually, like, a lot of those things that window managers do, like minimizing a window, can be done through the EWMH protocol because panels have to do it somehow. So we can do it the same way that a panel does. I don't think this is going to fully solve the problem. I do think that like, even if we do this, it's going to be still difficult to get things changed in X11. I think getting to a place where we have a good test suite is going to take a lot of time and effort, but I do think that we need it, that it's something we need to do to improve the quality of patches and just kind of give us a way to, like, create patches that we can be a little bit more confident aren't going to break anything. That's kind of all I have. I assume there might be some discussion after this. So I don't know, does anyone have any questions or responses? Everyone thinks this is a terrible idea.
No, principle is not a bad idea. The question is how is it done?
Okay. Alexander said, in principle, it's not a bad idea. The question is how it's done. Which I gave some vague suggestions of that, but I didn't. I haven't fully solved that problem. I haven't really tried.
I would say the main question is whether it's a Windows binary like the other tests, or whether it's a Unix program to exercise the X11 side.
The question. Alexander said the question is whether it is a Windows program like the rest of the tests or a Unix program. Um, I'm not sure the answer to that. I am leaning right now towards it being a Windows program, but we would have code in the X11 driver and possibly the Mac driver that allows us to access some things on the X11 side. I do think that my thinking with a Unix binary is that like it needs to kind of synchronize itself with other things that are running inside of Wine on the Win32 side, and I think that gets a little tricky.
I don't know. I haven't looked into that, but my first impression would be that it should be a separate Unix program that would exercise the X11 API.
Okay. I think that question is something we don't have to resolve right now. It's, you know, something for the patch review. Uh, Someone needs to build it, and then we can see.
What you want to do is to perform a Windows 11 operation and check on the X11 side that it does have the intended effect, side, or would you directly access the one X11 driver, not using Windows operation?
I, I'm sorry, I've already lost the question. I, it was. I'm trying to understand it. I think it was the question was, do we want to change something on the Win32 side, do some operation, and access X11 directly, or
Access X11 directly to check that it has the intended effect, like your full screen example.
access X11 directly to check if it has the intended effect, or
If you want to just
go through the X11 driver, I think you said, yeah. I think my thinking was that we would go through the X11 driver because we don't really have a good way to access X11 directly and access Win32 directly in the same piece of code. So any test we would write that way would have to be in two pieces, and they would have to talk to each other, and I feel that would get really complicated for no real reason. So I feel like we would do the change on the Win32 side that, for this example, is supposed to full screen the window, and then we would call into the X11 driver to ask the X11 driver, is this window actually full screened on the X11 side? And that is how we would do the verification.
So if you call the 32 Win32 API, it would have to be a Windows.
Say that last part again.
It would have to be a Windows executable.
Yes. Yes, it would have to be a Windows executable.
It also seems like that would require less changes to the build infrastructure.
Sorry?
It seems like if it needed a Windows executable, that would require less changes to the build infrastructure.
Yeah. Zeb said that if we needed a Windows executable, that would require less change to the build architecture. Yeah, I agree. That's why I think that that is the way to go. Alexander disagrees with me, but that is, I feel, something we can hash out on GitLab and mailing lists and stuff. So,
Are there other cases where we might need that besides X11 on Mac models?
Francois asks if there are other cases where we might need this. I think so. I think we for example might want tests of how the wine command works and how other built-in Unix side programs work, and I guess we've previously had that problem and approached it by making an exe version of the Unix program that we could then test. I can't think of any examples of a Windows DLL where we would need this sort of thing, but I could be wrong.
You're thinking about testing Unix programs?
Well, for example, we had I guess it did cause some regressions. We had a change to the wine command at some point that it would call start.exe to execute like anything that it can't immediately figure out how to execute, and that caused some regressions and some pain for programs that use the wine command like crossover. So that might be something we wanted to test. I don't think that is as essential. Okay.
All right. Thanks. Derek.
everybody for coming. I think we're resuming. And I said thank you for coming, and would like also to say a huge thank you to all the people that organized this very nice week. Jeremy, Arek, Tressa, Mandy, I don't know, whoever did something for that, please. Yeah, right. Please feel very much thanked. So I am Giovanni. I'll be talking to you a little bit about VKD3D shader and the HLSL compiler. So who am I? Up to a couple of years ago, I was a mathematician in the academia, and but I've always been in love with free software since ever I knew about this concept. So I like the wonderful idea of having knowledge that is shared with others instead of being, closed in some silo. Everybody has its own. And I've been contributing to the Debian project for a long time. Another thing I've always been in love with was making things work in unexpected ways. So making, for example, some program that was written for a certain operating system to work in some other place. You don't know if you know the concept. I mean, it's for example, what Wine does, what emulator does in a different way. There are many variations on this idea, and I found I love this thing. When I discovered about the Wine project, I always found a very cool idea. And at some point, I started contributing, and then nearly 3 years ago now, FOSDEM 2020, I wrote 2022, but that's of course wrong. I met some people from the Wine project who were there, and things started to go downhill from there. So lo and behold, a few months later, I was hired by Codeweavers. And I did a bunch of different stuff, and at some point I did some decent amount of work on the HLSL compiler. And that's what I'm planning to speak about a little bit today with you. Little note of care. There are probably a good amount of you who know better than me what I'm speaking about. So if I ever say something stupid, that's not so unexpected. So what is VKD3D? VKD3D is an implementation of Direct3D 12 on top of Vulcan. So it's sort of what WineD3D does for the early Direct3D versions. And again, on top of Vulcan instead of on top of OpenGL, although now WineD3D also supports Vulcan. It is mostly developed by Codeweavers with other people who are very welcome to contribute. And of course, it is what Wine uses to give the application running inside Wine, D3D12.dll implementation. Also dxgi.dll and d3dcompiler.dll, at least for some parts, rely on VKD3D. So the idea of having VKD3D as an independent thing is that you can actually use it without Wine. So that's meant to be a tool that you can use for porting an application from, for example, from Windows to Linux. If for some reason you don't want to take on embark the whole of Wine in your application, and Direct3D 12 is the actual big stuff that is very intertwined with your application. The other is something that you can port by yourself. VKD3D takes on the burden of doing the Direct3D 12 part. You do the rest, and you have ported your application to Wine to Linux, sorry, without having to actually take on the whole of Wine. And the licenses like Wine, LGPL 2.1 and later versions. So inside VK3D, there are a few different components. And the first one is the one I'll be concentrating about in the rest of my talk. But just to give a little bit of context, we have three main components. VK3D shader that does the operation of shader compilation between different formats. We'll see something more later. VK3D that translate Direct3D 12 calls to Vulcan and uses VK3D shader when it is required to process a shader, to use a shader. And VK3D utils, which is a much smaller library, which basically gives a few other tools that helps, I mean, this application porting business I just mentioned. This is not used by Wine, meaning that Wine also gives you what VK3D utils implements, but basically it's an independent implementation, although very similar. And so, as I said, each of these components depend on the ones that are above it, for reasons that I think are fairly obvious. So let's go to VK3D shader. This is quite a dense slide, and let's see more or less what it's capable to do. And then we'll concentrate on the HLSL compiler, which is basically one of the bullet points on the right. So as I said, VK3D shader converts between different shader formats, and so on the left I've listed a few of them, and mostly those that are relevant to VK3D shader. So we have Microsoft's formats, and of course Microsoft, as we know, always does things big. So there are at least 3 different formats, which were developed while graphics card got more and more features. So what was initially the earliest formats at some point were not able anymore to express the additional semantics that could be processed by newer cards. So we have the first bytecode format that is used for shader model 1 to 3. Shader models are these evolutions of basically what can ask a GPU to do. At some point, this got replaced with the what is usually called the XBC, but it's the XBC is actually the name of the container, and the thing that the actual program inside the container is in a format that is called TPF, that basically nobody calls with this name, and that's used for shader model 4 and 5. And then there is the XIL, which is the brand new thing. Well, maybe not that new anymore, but it's the latest one, and it still uses the XBC container, but it's the actual format of the program is basically based on a modified LLVM representation that's used for shader model 6. Except possibly for the really earliest formats, you don't usually write shaders in bytecode format directly, but you use some higher level languages. And what Microsoft came up with is this HLSL, that stands for high level shading language. And it's basically a C-like thing that then there is a compiler for, and gets compiled to this SM1 to 6, depending on what you want. Then there are the formats on the other side of the fence. SPIR-V, which is the bytecode format that you can use to give a shader to Vulcan, and GLSL, that is, I mean, so sort of corresponding source format, but that is again a C-like language that you can use to write shaders for OpenGL or through compilation to SPIR-V for Vulkan. Apple has, of course, its own set of stuff, because why not? And but you see that is in brackets because for the moment we don't really care about it in VKD3D shader. That doesn't mean that it's not welcome. It's can very well be something that we take contribution for, but for the moment we are not directly interested in doing development for metal. So what does actually VKD3D shader do? So the first line is basically a disassembler. So you take a shader model 1 or 4 shader, and you basically convert it to a textual representation that it's very like, I mean, any assembler language that you have ever used with. There are registers and move, add, multiply, and so on. The second line, SM4 to spear V, is what happens when VKD3D is actually running. It's actually receiving D3D12 commands, and it wants to do some rendering. Since it has to call into a Vulkan implementation, Vulkan will definitely not like to receive a Microsoft shader. And so VKD3D asks VKD3D shader, please convert this Microsoft shader to spear V, which is what my Vulkan implementation is willing to accept. And VKD3D, of course, is happy to comply. The third line is what I called before the HLSL compiler. So usually most programs and games ship with their shaders already compiled to a bytecode format. But not all of them do. Some actually use the D3D compiler.dll library and give them an HLSL shader and want to obtain a bytecode shader, SM1, SM4. Of course, then that bytecode will be given back to VKD3D for actual rendering, but still we have to implement this stage. And yeah, as I said, that would be then the topic for the second half of this talk. But I also would like to discuss some of the conversions that VKD3D shader cannot yet do, but are going to appear hopefully in the next months or years, who knows. So SM1 to spear V is the thing that is needed for the new Vulkan backend for WineD3D. So right now, VKD3D shader implements only SM4 to spear V because when you're using Direct3D 12, you cannot pass an SM1 shader. They are too old to be used for recent Direct3D versions. But if instead we, I mean, Zeb will soon talk about what's new in WineD3D, and one of the things I can anticipate you is I mean the Vulkan backend, and that needs instead to be able to accept also SM1 shaders. So it will have to have this SM1 to spear V conversion that I think Zebediah has already implementation for somewhat apparently. The other thing is SM6 to spear V. Currently we don't support it, but I mean newer features in Direct3D 12 will, like ray tracing and others, require us to be able to accept SM6 shaders, and Connor McCarthy is working on that. Some of his work is already public. I'll give you the link later. And so, as from what it tells me, it's not yet in a state in which it can actually run games, but it can nearly run demos. And hopefully, in a few months, it will be. I mean, there will be some games that can take advantage of that and work. Another couple of conversions are actually already implemented, but in Wine, not in VKD3D shader. And there is a general idea that it should eventually move to VKD3 shader, mostly because it's where all the other conversions are. And so that, I mean, those can also be used as independent things if anybody has ever has this need. The first two is the conversion of SM1 and SM4 shaders to GLSL, which is what WineD3D currently uses for its classical, let's say, OpenGL backend. And then there is also the possibility to actually assemble an SM1 shader, which is what I think used to be the normal way to build a shader in the old days. So I would like to concentrate now on the HLSL compiler, that is the third line of the right column, and which is the actual thing I've been spending some time onto for the last more or less year. And my work on that is still is not yet fully upstream, though nearly. There is also some work by Zebediah and Francisco that is ongoing, and upstreaming work is ongoing too. But first, time for a little pop quiz. So if you had to take a choice, would you think that HLSL is a nicely documented format with a good and extensive reference manual that is precise, that it goes in depth with a lot of examples that are coherent with what the compiler actually does, or the other way around? So if you think that HLSL is well documented with a lot of good examples, please raise your hand. Yeah. Well, it's more than I expected. It's well more than I expected. So somebody tried to propose that it could be worse. Okay, let's accept that. But of course, there is a lot of work that we have to do to reverse engineer everything that is not well specified. Well, basically, I mean, I checked again today, and basically, if you look for HLSL on the Microsoft documentation thing, basically they say, yes, it's a C-like language, and here are a few examples of how to use it. Figure the rest by yourself. So there was, as usual with Wine, there is quite a deal of work of reverse engineering on our side, and as usual there is a lot of tests that are used to learn about what the language actually does, and check that our work is synchronized. Sorry, want to check the time with what the native library is doing. So if you actually want to use the compiler, you have a couple of options. The first one is actually VKD3D ships with a standalone program which is called the VKD3D compiler, which you can use to trivially do whatever any compiler does. That is, you give it a file, which is your source code, and it will spit out either errors or compiled version of your shader. And I mean, we can have a look. Sorry, I have just one hand, and I wrote the and there it is. It's writing out fix.me, which actually is harmless in this case. So it should have compiled the shader correctly. And this fix.me will eventually be solved when Zebediah's patches get in. But okay, this is not very funny. The much funnier thing is the second line, because look, we have colors. This is the disassembled version of the shader that just got compiled. So I'm basically showing you a few of those arrows that were in a couple of slides ago. And so you might have the feeling that this code is not really optimized, and that feeling might actually turn out to be correct. You can see there are a lot, basically, of I think that the semantic of the language are pretty transparent. Of course, there are a lot of values that are usually moved back and forth between registers for no good reason, except that we haven't written better optimizations yet. And you can also notice this is completely not vectorized. I mean, the assembler language supports vectorizing, I mean, doing more than one operation per line. But the conversion should be correct. I guess it's correct. and that's the output. Of course, as I said, VK3D shader also enables you to convert this Microsoft bytecode shader to SPIR-V so that it can be fed to Vulcan, and we can have a look at that too. Okay, this is not very interesting, but in the end we can see what's in the SPIR-V shader, and we have color again. And it again is terribly not optimized. It's not really a problem if you think about it, because when actual rendering is going to be done with this shader, we'll actually pass it to another compiler that inside Mies or inside the NVIDIA driver, whatever. And we trust that they have actual optimizers that do their job. So, I mean, other than a little bit more of processing cycles, this is not expected to cause real problems once the shader is executed. Still, it's in our plans to do something better eventually. Okay, and that was the fun part. If you want to have additional insights of what's happening inside of the compiler, there is the usual environment variable that you can set to have a lot of a nice message in the log. So that was the first way to use to actually compile shaders. There is another one that is the one that you use if you're actually writing a program that wants to compile shaders. And basically the main call exposed by VK3D shader is VK3D shader compile, unexpectedly. And it is sort of based on the extensible structure thing that is used in Vulcan for those who are, used to that. So basically, there is. I mean, we assume we have a source code in a car vector. It's actually useful to go backwards. We create a structure of type VK3D shader structure type compile info. We love to type a lot of characters that basically has a reference to the source code and says that the source type and target type of the compilation are. Since this is an HLSL compiler invocation, we also have to give it a couple of satellite information, like what is the entry point and what is the shader profile. And in the end, we call a VKD3 shader compiler, which will magically do everything we want. If specifically we want to use the HLSL compiler, there is a we can go through the library that mentioned before, VK3D utils, which does it's a bit more allows for a bit shorter code and takes basically all the input stuff in a single call, and internally calls the thing that I just showed you a couple of slides ago. So let's conclude by mentioning what is the HLS compiler currently able to do, and then I tell you what is still missing, and that's basically it. So what is here? Well, it's is already something. I mean, it's able to actually enable a few games. We have a few games that are that can work with our HLSL shader compiler. It does, of course, parsing and code generation for SM4. In theory, it also does SM1, but it's less complete. Although Francisco is working a lot on that. It supports all the fundamental types like scalars, vector, and matrices, arrays, and structures. This is fairly working. It has basic control flow, so the usual stuff that you know from C. There are a number of operations, arithmetic and logic, and type conversion casts that are working. There is this vector swizzling thing that it doesn't exist in plain C, which basically means that you can take a vector object and permute its components. It supports complex initializers. That is the funny thing that in HLSL is even funnier with braces that you can use to initialize a variable, like a structure or array. Then the language has the thing that are called intrinsics, that are basically some predefined functions that you can use, for example, to I could have actually showed you the code that I was compiling, which is this one. So you see that it's rather C-like, and you see, for example, there are something like this mul that does matrix multiplication, or normalize, that normalizes a vector. All these, of course, are not in plain C, but are available to the HLSL programmer. And our compiler is already able to handling a few of them, and others are upcoming. It can do texture and sample texture, load from textures. Again, it can already do something, and something more is in the pipe for being accepted. It implements the C preprocessor that, of course, you can use. Well, not of course, but you can actually use with the HLSL compiler. And we already have a few optimization passes, like that code, copy propagation, and constant folding that are working. Otherwise, it would be even worse, that compiled code. What's missing? We don't have function calls yet. Actually, we won't implement actual function calls, but rather function inlining, but because that's what the native compiler does anyway. We don't have not really advanced, but not basic flow control, like break, continue, and return. Some of these are coming. Actually, return is basically part of function inlining. We have still a lot of intrinsics and methods to implement. There is this completely crazy thing about function overloading, which, the language supports differently from C function overloading, but getting the details of that is a huge mess. Of course, the documentation barely acknowledges that function overloading exists. And we have no idea of what, because there is not just function overloading, but also implicit function parameter conversion. So if you have a lot of overloads, it's completely not clear what is the overload to be that can be chosen, considering that you can also implicitly convert arguments. So as far as I know, every time any of us had tried to do something with function overloading, it has quickly backed up in horror. And hopefully, I don't know if I've ever found a program that used function overloading in a shader. There might be a gentleman's agreement that this is just something people do not touch, and we can get away with that. But yeah, for example, for the moment, it's completely missing. And there, of course, there are usual bunch of detailed corner cases that we discover while we do stuff. Though we have tried to take a conservative approach, meaning that we try to make sure that if the compiler does not fail, it does not print any fix me, it doesn't return an error, it doesn't crash, then it returns a correct program. And I think more or less this works. And of course, another thing that has to be done is vectorization, as you may have noticed before. Some of these things already happened in our development branch, in particular in the branch that we put into Proton, and some are still to do. And of course, if you want to give a try, we are happy to receive your patches. And I mean, last few things, though, I mean, there is nothing really astonishing here. We, I mean, at the level of source code, we basically have a couple of Flex and Bison thing to do parsing, once for the preprocessor, once for the language. So, I mean, for who is not, who doesn't know, this .l and .y files are basically standard way to convert a program in text format in a structured thing that can be later processed. And there is a HLSL code gen.c, which is basically where a number of lowering optimization paths happen, and where basically the program, the parsed program, is prepared for being from being passed to the actual code generators that are different from shader model 1 or 4. Then there are the code generator for shader model 1 or 4. And HLSL.c contains a lot of miscellaneous stuff that is just used everywhere else. If you want to have a look at the sources, or even better to contribute, you find links to the upstream repository, which is where, I mean, we just released version 1.5, and where the actual development goes on, and patch submission happens. You can have a look, especially if you want to run games with it. You can have a look at the branch that we're currently shipping in Proton, which is basically upstream plus the patches that we are still. Most of them are actually relatively ready to be upstream. They just take some time to do the revision. But I mean, basically, what is in the Proton branch is what will be upstream shortly. And then there is Connor's preliminary work on the XAL that he already made public on that branch, again in Wine's GitLab. That's all I had to do. I'm happy to take questions if there are any. Yeah. So the question if there is something to compile to SM6, and the answer is that no, we're not working on that right now. Also because Microsoft has an open source, a free software compiler for that. So it's, I mean, it's, if
There's two things there. First, application is usually just ship the bytecode with SM6. And second, they can actually ship the Microsoft.
Yeah, as Henry noticed, usually applications just ship the compiled bytecode, and furthermore, they can ship the compiler. Actually, they can also ship Microsoft's compiler. I mean, Microsoft D3D compiler.dll. Sometimes they do, sometimes they don't. But again, it's not a priority, mostly because if it ever becomes something that we want, we're probably willing to take the Microsoft version that is already free software. Yep.
Is Connor work using the DXIL Spearbeat project by Hans Christian, or is that a new effort to translate?
So the question is if Connor is using the DXIL project by Hans Christian Arntzen, and I guess the answer is no or yes. You know, I haven't. Part of it. Okay, I'm not confident. I do not know a lot of that. He's recently, I mean, he's recently came to a point where things are starting to work. Yeah. Yep.
Have anybody done benchmarking between DK D3D compiled shader versus the Windows one?
Okay, the question is about relative performance between VK3D shader compiler and Windows. Do you mean performance on how quick the compiler is at compiling, or how quick the shader is while rendering? Okay, the second one, I don't know, and it's something that is very difficult to benchmark anyway, because they're going to, in principle, completely different implementations anyway. So the shader that we compile will be, again, recompiled, I don't know how many times, but definitely more than one, by the backend driver implementation, and so it's not clear what to compare. I mean, it is part of the more general question on whether the whole VK3D implementation is more or less performant than a driver, than Windows drivers. And again, it also depends on the Vulcan driver, so you really get to decide what you want to really compare. And I don't know of anything, I mean, any specific systematic answer to this question. So the question is about what is the reason why we don't care too much about metal shading language. And I think that the main answer is that right now our plan to use to support Apple devices is through MoltenVK. So we're basically treating it as a Vulkan implementation, and then the conversion between Vulkan shaders and the shaders that the Apple driver actually needs is the job of MoltenVK. I don't know if there's any other specific thing to comment on that. But again, as I said, it's not necessarily something that we don't want to have. And I mean, it might, even the question whether we want VK3 backend that directly renders to metal instead of passing through MoltenVK is a question that can be, I mean, it is something that could be done, though, and maybe there was also some prototype at some point. No, not, okay, not for earlier versions, yes. But for the moment, it's not where we are concentrating development. Yes, MSL is a source language. So the question is, if we wanted to go directly through metal, would we use that source code? The answer is that I don't know. I mean, everything should be engineered from scratch at that point. Metal also has a bytecode version. I don't know if it's specified, if it has public specification. So I mean, nothing is known about that. It's too hypothetical to have an answer. It's not. Okay. Mm-hmm. So it's an LLVM-based thing, but it's not publicly specified. Yeah. Mm-hmm. Okay, so again, for the benefit of the stream, MSL is basically based on C++, and it gets compiled to something based on LLVM, but all these steps are proprietary and not reverse engineered. By the way, anyway, the idea to compile to a source level format is what WineD3D is currently doing with OpenGL anyway. So it's not unheard of, and it works. I don't know if, I mean, one could argue that it's less efficient. Probably not relevantly, I mean. Any other question? Yeah, I think that time is up anyway. Yeah, if somebody comes up with something.
Well, people could talk afterwards.
Yeah, okay. Thank you a lot.
I am more audible? No.
That's only for the stream.
Oh, the stream's not on yet. Okay.
Yes. You can, it's okay as speaker to remove your mask if you like.
Yes, I suppose so. Are you ready?
Please.
All right. Well, good morning, everyone. My name is Seb Figuera. I'm here to talk about the progress you've made in Direct3D since the last WineConf talk 3 years ago in 2019. As you can imagine, for 3 years, we've had a lot of progress. And I'd just like to, summarize and touch on some of the biggest new developments. Obviously, for a 30-minute talk, I can't talk about everything, so I'll just talk about the biggest things, and for everything else, you can refer to the change logs and the release notes. So just to give a bit of background about myself, I first joined the WineConf project a little over 5 years ago now, in early 2017. I was recruited by Codeweavers several months later. I've worked in a lot of different areas in wine, perhaps almost all of them by this point. I've spent a lot of time on multimedia and low-level I/O and plug-and-play. Those are some particular interests of mine, but since early 2019, I also spent a lot of time working on the Direct3D infrastructure. And earlier this year, longtime Direct3D maintainer Henri Verbeet passed on the role of maintainer to myself and Jan Sikorski, the latter of whom is unfortunately not available to make it to the conference. So, with that out of the way, let's talk about Direct3D. Oh. Yeah, this is how that works. So the biggest and most exciting thing we have to report is the existence of a new Vulcan-based renderer for Direct3D. All Direct3D versions, but right now basically just 10 and 11. This lives alongside the GL renderer that we've had a long time. We've spent some work separating the two and adding that infrastructure. In its current state, I think it works as well or better than the GL renderer for most programs at this point in time. So you can enable it and test it either by a registry key or by, we have now an environment variable that may be easier for some people to use. We had a code name for it, well, it's in development, so we called it Damavand. We still sometimes call that as a nickname. So if anyone has heard this name before and has been confused about what it means, it's just the Vulcan backend of WineD3D. There is no equivalent code name for the GL backend. It's just a Vulcan backend. We currently don't have 3D support for Direct3D 9 or 8 or anything lower than that. So in theory, you can run Direct3D 9 applications, and in practice, some actually do. One notable example of this is the Direct Show video renderer, which uses Direct3D 9. Will actually work with the Vulcan backend. I tested it recently. But the main reason that most Direct3D 9 or lower applications won't run is because we don't have a shader compiler for SM1, as Giovanni mentioned, and we also don't have a fixed function pipeline replacement. So there is in progress work to compile shader model 1 shaders to SPARV, which the Vulcan backend can consume, and the plan is also, once that's done, to implement a fixed function replacement using HLSL, which will also allow us to replace the by now rather complicated GLSL compiler, fixed function compiler. But on the other hand, given that Direct3D 9 support over OpenGL generally works pretty well, it's not been a huge priority thus far. it's one thing to note is that we use the VKD3D shader library. As Giovanni gave a great summary of that, we use that to compile shader model for bytecode to SpireV. So there's an optional out-of-tree dependency, although as of earlier this year, we bundled VKD3D shader with Wine. So, and you can also build it independently if you want. So why did we develop this Vulcan backend? Well, it may seem very exciting, but we developed it out of necessity because OpenGL is abandoned both by Kronos and perhaps more importantly by Apple several years earlier. While there are certainly advantages to Vulcan's API design, the way it allows finer grained control over the hardware, that would probably have resulted in us writing a Vulcan backend eventually. But there are advantages and disadvantages to Vulcan, and one of the biggest disadvantages is the amount of time it took to write this Vulcan backend. And so I would like to take some time to talk about both of these. So the Vulcan renderer is capable of a few things that are currently unimplemented in GL. Some of these things are difficult to implement. Some of them are missing from the GL specification. But most of the things are not really impossible to implement in GL. Or, big new features. There's no, so some of the big new features in Vulcan are support for mesh shaders and ray tracing that is not in GL and probably never will be. But those are not things that Direct3D 11 or lower uses, only Direct3D 12 and up. So most of the things that tend to work better in Vulcan are inconsistencies or poor design to GL spec, and I'm not going to get into examples because that would be very technical. But there are certainly some games that work and render correctly with the Vulcan renderer and don't work with the GL renderer, which is great news because they're fixed now. We don't have to fix the GL renderer, but we would also kind of like to fix the GL renderer because some of these, partly because some people are not capable of using a Vulcan renderer. Some people don't have working Vulcan drivers for one reason or another, and the hardware is capable of it, and we would still have liked to have these with GL. The other main benefit of the Vulcan backend that we've observed is that the performance is better. We have not really done a lot of effort to determine why in some cases, simply because we don't have that, time available to just do that testing. But I think the main reason is basically that we've just had time to put more work into Vulcan-specific optimizations. There are a lot of things that we could optimize in GL backend as well, but we haven't had that time to spend on it. And once the Vulcan backend works better, it's often better for us to just keep working on the Vulcan backend. Now, with the benefits out of the way, let's talk about the drawbacks. Well, so most of the drawbacks about Vulcan aren't related to the functionality because Vulcan is capable of doing everything that OpenGL can do on hardware which Vulcan supports. It's more, things about the Vulcan environment that are a problem. One thing is pipeline compilation is very expensive, so this causes notable stutter in application. You can mitigate this by writing in a disk cache, but this has a cost, which I think is often ignored in terms of disk space, in terms of startup costs. When you run it the first time, you still have to compile to populate the cache. And, like all things, it takes time and effort to develop, which we would like to be able to spend on other more important things. The fortunate thing about this is Vulcan is a mutable API, and there are some recent Vulcan extensions that will help address this in a more efficient manner. that don't require cache. Another thing about Vulcan is that it's not universally supported, which is not necessarily a concern if there are working OpenGL drivers that can, cover the deficit. Excuse me. But on the other hand, there are also some basic features missing from OpenGL, and if we don't have a Vulkan driver either, we can't do anything about it. And, implementing a new GL extension is not really an option. In one particular instance, there's currently no free software driver for, well, when I read this talk, there is no free software driver for NVIDIA GPUs. There's recently an announcement of a NVK driver that uses some open firmware. Of course, this also only supports the very newest generation of NVIDIA GPUs, so it won't support anything lower than that. So anyone wanting to use Direct3D software on NVIDIA hardware who is unable for one reason or another to use NVIDIA's proprietary drivers will only be able to use the OpenGL backend. And I'd like to take a moment to address a related point. There are some people who have the impression that Wine's Direct3D implementation has or should have the primary or only purpose of supporting old hardware. There, on the other hand, other people who assert that, any translation layer should only support the most recent hardware and drivers, and often fail to realize how old of hardware is actually in use by people. We Wine Direct3D developers, we take the position that everyone's hardware is worth supporting. We're not going to customize newer hardware just to optimize support for older hardware, but we also aren't going to drop support for older hardware just to make it easier to support newer hardware. We're going to try to support everyone's hardware as best we can with the best performance and the best compatibility that we can. And anyway, perhaps the most important disadvantage from my perspective of developing the Vulkan renderer is that it took a lot of time and effort to develop. Vulkan is a completely different API than GL. It makes the application developer do a lot more things manually. It uses a binary shader format, which is a lot harder to write shaders in, which is especially a concern when we do have, complex high-level shaders we have to compile at runtime for things like the fixed function pipeline. We spent multiple years of time on the Vulkan backend, which we would like to have spent on other high priority tasks like improving Direct3D 11 support, improving performance, implementing the HLSL compiler. All these things basically had to get delayed. Vulkan is a huge improvement over OpenGL in terms of API cleanup, and I don't want to discount that entirely, but I think there's an associated cost with switching APIs like this that is often ignored or downplayed. So I just like to make that point. I'd like to stop here and ask for if there are any questions about the Vulkan backend before I get into all the other exciting news about Windy3D. And if not, we can always wait till the end to ask them too. All right, I'll just go on. Right, so besides the Vulkan backend, one of the biggest things that we've done in recent years is improving our performance very much. So the biggest item on this list by far is what I call map acceleration. So like most modern GPU drivers, we have what's called a command stream, where we basically take application D3D calls and we record them onto a list, and we have a separate thread that executes those so that the main thread isn't blocked actually processing the D3D commands. The main reason this is actually written is because OpenGL is not the most thread-friendly API, and it turns out that for various reasons, we basically need to execute all GL calls on the same thread to do things correctly. But it also has the secondary benefit that performance can be a lot faster with certain applications. Unfortunately for us, this performance benefit that we were getting was often, nullified because a certain operation, resource mapping, where you take the image or a buffer on the GPU and access it directly in the CPU as if it were, or using CPU memory. Basically, you had to do most operations are asynchronous, but resource mapping is synchronous because you have to wait for a result from the CS thread. And that means we have to wait for all of the previous CS commands to finish. This has been the single biggest performance bottleneck in games, especially newer games like Direct3D 10 and 11. Earlier this year, we submitted patches that get rid of this bottleneck. So now most of the important maps will be asynchronous, and they will not have to wait for the command stream to finish. And as a result, there are a lot of games that are a lot closer to their Windows performance. So that's very exciting, I think. There's a lot of other things we've spent effort on performance-wise. I don't want to spend time listing them all, especially because some of them are very technical and a lot of them are very, game-specific. One of the things I would like to note is that we currently take a big windy 3D lock that around all operations, and we've started taking steps recently towards removing that lock. So we've removed it from deferred contexts, which are often used by multiple threads. And in the future, we would like to take more steps to break up that lock into more granular pieces. I don't need to talk much about the HLSL compiler because that was the subject of Giovanni's talk and he covered it in great detail. But I'd just like to give a quick summary. This is something that we have been working on largely over the past 3 years. We had a very basic parser implementation written in 2012, but it wasn't capable of generating any code. But we've wanted to, improve that for a long time, and now we have a HLSL compiler that can compile real shaders, and also cannot compile real shaders, other real shaders. So, a lot of exciting work done, and a lot of exciting work that's still to do. In the world of Direct3D 12, we've made some major strides since 2019. We have not had a lot of effort available to spend on Direct3D 12. But in the past years, we've had Connor McCarthy, who has helped to improve performance by rewriting the descriptor heap implementation. He's helped improve fence performance and compatibility by rewriting the fence implementation using a newer Vulcan extension, timeline semaphores. And we also have support for shader model 5.1, which was missing from the 1.2 release, and descriptor arrays. So there's games using those will now work. Currently, the biggest blocker for Direct3D 12 is we have no support for shader model 6, or DXIL, as it is alternatively called. It's a completely different binary format, but as Giovanni mentioned, we're excited to report that this is being worked on. We actually have a complete branch which can compile real shaders. Very exciting. And we hope to have the rest ready soon, for, some definition of soon. So apart from the functional changes and new features in the VKD3D library, so those have already largely been covered. I would like to share 2 other pieces of news, changes in the way we're doing that library. So the first thing we've changed is that as part of the PE conversion, you can the latest version of you can build VKD3D and all its libraries as in the PE format, and we do that for Wine, and we actually bundle the libraries with Wine. So you can now build Direct3D 12 capable Wine without needing to worry about external dependencies. But also, if you would like to use external VKD3D, you can do that as well. The second piece of news I'd like to share is we've changed the release schedule. We did not have a stable release schedule prior, due to low amount of available work, and we had a lot of difficult API design questions that went into, especially the shader API. And I think there's also a desire we had some features in the pipeline that we were hoping we'd be able to get into the 1.2 and 1.3 releases. So as a result of all that, 1.2 and 1.3 were very slow to be released. So we've changed that recently. We have a strict time-based release schedule like Wine. We release a minor version every 3 months. The month before release is designated a soft API freeze. So any new APIs or API changes should be ideally ready before the freeze ends. Sort of like a merge window. And anything new will be deferred until the next deferred from the freeze until the next merge window, as it were. And we also, freeze the implementation, so as most projects do, so we make sure that the release is as stable as we can reasonably get it. And finally, I would just like to mention some of the other work that has gone into the general GPU acceleration subsystem outside of that are not Direct3D specific. So I think Alexander has already given a decent summary of how PE conversion and WoW64 support works. So most of that is finished, but one of the last and most difficult parts that we have not finished is the GPU libraries. There are two things that make the GPU difficult. So first of all, the list of functions in comparison to any other library is very, very large, because we basically need to thunk every GL, CL, Vulcan, etc. function directly. And also these lists, at least in the case of some APIs, are constantly changing as new extensions and Vulcan versions and CL versions are being added. So, and Vulcan especially has a very complex API surface with its chain structures and structure arrays. So there's a lot of work that goes into generating those thunks from an XML format. The other thing that makes these libraries difficult is that most of them involve, some sort of mapping a resource, which is something I sort of touched on earlier. And all of those resources return a pointer from the Unix side or from the 64-bit side, which in WoW64 means we are giving a 64-bit pointer to a 32-bit application, which won't know what to do with it. Fortunately, all of these APIs have are designed to be extensible, so we can introduce an extension and actually fix this problem that will allow us to specify where the pointer is placed and make sure it is a 32-bit pointer. So we have several people, including Jason Ekstrand and Derek Lisho, who are starting work on a Vulkan extension. We don't have any extension for GL or CL yet. We will need those. Another thing that that has happened in the past 3 years since 2019 is we have a bit better support for OpenCL. There is an OpenCL wrapper library on Windows. It's very rarely used, but it exists. And this was recently upgraded from 1.0 to 1.2. And we also support some extensions where we previously did not support any. We are still a long way from the current OpenCL 3.0. And there's a lot of extensions we don't support, partly because basically we don't support anything that involves sharing or anything that involves, anything extension that has its own function pointers. That takes a bit of extra work to generate. And finally, I'd just like to give a mention to the efforts of Liam Middlebrick and Georg Lehmann, Georg Lehmann, who have been working tirelessly to keep our Vulkan wrappers up to date and implement support for more extensions. And that's all the news that I have time to share from Direct3D and GPU. So, if anyone have questions about, or anyone have questions about this presentation?
What's your roadmap? What's next?
So, yeah. So the question is, what is our roadmap? Which is a good question. So one of the things we'd like to do, so we'd like to finish the shader model 6 support, and we generally put more work into supporting newer features in Direct3D 12s, such as mesh shaders and ray tracing. We would like to get the Vulkan backend supporting Direct3D 1 through 9, DirectDraw, Direct3D 8, Direct3D 9. And this involves supporting more formats in the VKD3D shader library as well. Excuse me. We'd like to introduce more support in the HLSL compiler. We have a lot of work that's needs to be upstreamed and a lot more work that's yet to be done. We would like to keep working on improving Direct3D performance. I think our performance is a lot better, and in some cases reaches parity with Windows. But there's also many things that can still be improved. There are probably other things that are on our roadmap. Our roadmap is very, very long, but I think those are some of the things we would like to focus on in the near future. That's a good question. So the question is, will DXVK become obsolete due to improvement of WineD3D? That's a difficult question to answer, as I'm not a DXVK developer and I don't know their plans. I think in WineD3D we would like to do everything that DXVK does, which is, support Direct3D 10, 11, 9 applications over Vulkan, and we'd like to do it with the best performance that we can. So in that sense, the answer is yes, maybe. And in a sense, we would also like to support things that DXVK does not, such as mainly support for older GPUs, and older drivers, which is perhaps less important for some, but can be very important for others. Right, and older D3D versions are something we currently support that DXVK currently does not. So in a sense, we would like to do everything that DXVK does. It's not I don't think it's our intention to, make DXVK obsolete in any sense. We'd welcome DXVK as a part of the Wine ecosystem, but we both have the same goals, I think. Or perhaps well, I think we have a superset of DXVK goals. I think that's the thing. A lot of people say, wine is focused on correctness, DXVK is focused on performance, or wine is focused on older GPUs, DXVK is focused on newer GPUs, or wine is focused on applications, DXVK is focused on games, and and that's broadly not true. We're focused on everything, including that which DXVK is focused on. But that does mean that DXVK is putting more effort into some of those things than we are, but we still care about them. We want to implement them eventually. Yeah. I hope that's a reasonable or helpful answer to your question. Yes, Connor.
Has it been difficult maintaining two backends
yes, I think in a lot of so the question is it difficult maintaining two backends, and do they map well? There are certainly some things that maintaining a GL backend makes difficult that would be less difficult if it was just Vulkan. I mean, I think threading is the big one, because if we are forced to put everything on a command stream thread. But it's the tricky part is that a lot of the difficult problems we had to solve for OpenGL are also the exact way we want to structure things for Vulkan. Like, we want a command stream thread for Vulkan anyway because of the performance part. We have, you know, context management. That's very technical, but the broad answer is a lot of the problems we had to solve for OpenGL are ways the Vulkan renderer it fits well into that design. So yes, absolutely. So Henri said it's very useful to have a second implementation we can compare with, and that is actually a very true thing. It's great to be able to, you know, run a program in with both backends, and, you know, if it works with one but not the other, you know, well, there's something wrong in a GL code, or there's something wrong in a Vulkan code, which is, I think, one of the biggest reasons that I would really like to get the Vulkan renderer working for Direct3D 1 to 9. There are things I say, well, is this a GL specific problem, or is this a problem with the common code, and so on.
Questions? Everyone's aware that there's donuts out there and they're thinking about that. Although the donuts might be gone, so you may be too late.
Yes.
You mentioned there's no free NVIDIA driver. Do you know if Nouveau is working on support?
So from what I hear, I've heard at this conference that they have NVIDIA, the company, released a driver for very new GPUs that is open source, and the Nouveau or Mesa project seems, as far as I understand, is going to write a Vulkan driver that utilizes that code or is based on that code. I do not know if the Nouveau project is working on a Vulkan driver for older GPUs, so that I've not had. I only just learned about the Vulkan driver. It's only newer, so there's no plan to support older GPUs. Not right now. Okay, yeah, there may be a plan to support older GPUs in the future, but, you know, that's we have to work with what we have. Oh yeah, Hugh. The comment is, okay, so the question is, I have a lot implemented that's not upstream. How much? I think that comment was about the HLSL compiler, and it's I'd probably say I have on the order of 50 to 100 patches, which is kind of a lot. There's some reasons. There are a few reasons why that didn't get upstream quicker. Partly we had some trouble we had some trouble figuring out a reasonable review process for patches from 3 different people to the exact same area, which is not the kind of thing that usually happens in Wine. And there was also, because we were in the early stages of the HLSL compiler, there were a lot of design decisions that, you know, things we ended up wanting to change that we wanted to get in first. I don't think I have, in terms of core Wine3D, I don't think there's a lot of patches that we have that aren't upstream. There are some performance improvements. Well, yeah, a lot of those are kind of guesses, or we don't really know if they're improving anything, and a lot of them need to be cleaned up. But we do have a lot of those upstream already.
More questions? Thanks, Eb.
Thank you.
I'm Brendan Shanks. I work at Codeweavers. Been there since 2019, working on Proton and Wine in general, and then also the Mac has kind of a focus for the last few years. And I want to give an update, sort of a refresh about some of the changes on the Mac that Wine has had to adapt to over the last few years. The main one being the removal of 32-bit support on Mac OS. This is a bit of a history lesson, but it's been a few years since our last conference, and there's a lot of new people. So I figure we might as well cover it again. So in 2017, Apple announced that macOS High Sierra would be the last release to run 32-bit apps without compromises. That was pretty vague, but it put everyone on notice. And then a year later, they announced that Mojave would be the last release to run 32-bit apps. So why does this matter? Wine runs 32-bit Windows EXEs in a 32-bit Unix process and 64-bit EXEs in a 64-bit Unix process. 32-bit Windows software is still extremely common, even if you're running Steam and it's using a 64-bit Chromium and it's launching a 64-bit game. Steam.exe is still 32 bits, and there's lots of installers and launchers and support programs that still need to be 32 bits. So for a generally usable Wine, you really need the 32-bit support. And the situation is in 2019, macOS Catalina is no longer going to run 32-bit processes. And this is a big problem. What are we going to do about this? A lot of this happened before I was at the company, but there was very smart people who had been working on this for a while. I think the first question to answer was just how to run 32-bit code, period. There was some early experimentation and prototyping done using virtualization, using the macOS hypervisor framework and running 32-bit code inside there. It seemed like that actually was promising. It was able to run some simple applications, but there were a lot of concerns around performance, particularly the latency of exiting and then re-entering the VM, which for an actual guest OS would be a lot rarer than it would be for Wine doing this on every call into like an external DLL. What ended up happening was that Apple added support to Catalina that allowed 64-bit processes to create 32-bit code segments, and then we would be able to do a far jump or long jump into the 32-bit segment. It switches the processor to 32-bit mode, and then return. This is pretty much ideal. Linux has similar support also for user space processes. It's similar to Windows, gets the processor in 32-bit mode. So that was sort of handled. But of course, a big part of Wine is not just running 32-bit code, but also implementing Windows APIs and eventually calling into Unix APIs to implement those. At the time, this was the Wine 4 era. Wine was made up of what we call WineLib DLLs, which were built into ELF or Mako dynamic libraries. They implemented Windows APIs, and they were able to call into either Windows or Unix APIs. Very powerful and convenient, but in the case we have here, the Windows code is using 32-bit pointers and calling conventions. The structs are 32-bit. But on the Unix side, all that stuff is 64-bit. And that's a big mismatch. I have sort of a diagram of just showing inside a 64-bit Windows or Wine process, you'd be running a 32-bit Windows exe, say it calls something like get font file data. That's implemented in GDI, which is a Unix dynamic library, and that can call into either other WineLibDLL like NTDLL or FreeType, which would just be a normal Unix library. And of course, on that side is all 64-bit libraries, and FreeType at least is a 64-bit library. And so the solution that was masterminded to sort of handle this was called the hybrid compiler. It's sort of masterminded by Ken Thomases and Chip Davis and others. Found myself looking at Ken's old emails to sort of figure all this out. The compiler was a fork of Clang 8, and it implemented a special 32 on 64 mode, where every pointer is essentially assigned an address space, which would be either 32 or 64-bit. 32-bit pointers could be assigned to a 64-bit one because you just widen it, but the other way was not possible, only through converting it through an integer. And did that pretty rarely, sort of have to know what you're doing, and we had a pretty explicit macro in that for wine. Variables and functions also had an address space. Variables were usually 32-bit if they came off the stack. All of Wine's threads would create a 32-bit stack. There were cases where if code is running from a thread that wasn't created by Wine, typically, example would be on the Mac, like Core Audio will call you back from an OS thread to get audio samples. Similar thing in the windowing driver to get layer surface contents. In that case, the stack is 64 bits, and that just kind of made things more complicated. And function pointers also had an address space depending on what kind of library they came from. And so how would you assign an address space to each pointer? You don't want to have to manually add attributes all over the code. It was inferred based on header files and where the function or data type was defined. For system headers, anything that came from there would be considered to be 64-bit, and that includes with angle brackets. So of course, that'd be all system headers. Wine's headers, we added pragmas at the top and bottom of all of them to mark everything in between as being 32-bit. So all the Windows data types, if you find a pointer to those, it would be considered to be 32 bits. And there's other complexity too. I think there was a class of includes that was local, which would be files just in the source tree. So as for the generated code that the compiler generated, these functions and libraries, they would call 64-bit Unix APIs. They have 64-bit pointers. So it needs to be 64-bit code, and the processor needs to be in 64-bit mode, but they're being called directly from 32-bit Unix code, or sorry, Windows code. So what the compiler would do is generate thunks for every function that used a newly added 32-bit compatible calling convention. Generate a thunk just named wine_thunk function name. And the thunk would do the far long call from 32-bit mode to the 64-bit code segment, call the function, and then do the far return back to 32-bit mode and the original call site. In order to know what the actual code segment selector was, that was stored in like a global variable, and we would supply the name of that as a compiler option on the command line. Now to show what this sort of looked like in code, I have this is the actual signature of get font file data from GDI32. It's on the screen there. So it's got the WinAPI attribute. In the 32 and 64 mode, that got defined to be, it's hard to see. There's it's std call 32, which was newly added versus the regular, just standard call. And that would trigger the compiler to generate the thunk, and also to know that all those parameters were going to be passed through the 32-bit calling convention. We've also got a void pointer over there, and that's, of course, going to be 32 bits. I've left out pretty much this whole function, but the heart of it is calling into free type to get font data. That's also got a pointer, but in this case, of course, it's a 64-bit pointer that it's going to fill up. But in this case, we can pass the same pointer. Free type is going to fill the buffer provided by the application directly. Now we're calling this through a function pointer as well that was dynamically resolved through DLSim. So in that case, it didn't come from a header file, and it is interesting to look at higher up in the file where that was defined. You can see we've got the pragmas, which push a new address space on. This is the default one, which is the 64-bit. There's a void star handle, which is what's returned from DL open, which is, of course, going to be 64 bits. And then the function pointer itself, which is 64 bits, and all its pointer parameters as well. A whole bunch more of those function pointers. And then we pop the address space. Generally, there are two ways of doing this in the source. You could either attribute each pointer with an attribute for either host pointer or Win32 pointer, or for cases like this where you had a whole bunch, you could just push a new space that would be the default between there and then pop it off. And of course, the compiler did type checking on this as well. I tried moving that DL open handle outside of the pragma, and it would return this error message, which doesn't look too bad. A lot of these, once these got more complicated, they were very, very dense, but just, you can't assign this, it changes the address space to the pointer. So in practice, this really worked pretty well. We were able to avoid a lot of too many changes, or at least broad changes all over the source code. But there were still many special cases that did need changes. In particular, if you got data from a Unix library, like a font name from free type, and you wanted to pass it to a Windows function, say string conversion, to copy it to a Unicode buffer. You couldn't do that directly. One way to get around that would be to make a temporary copy of it, just allocate a buffer on the Windows heap, copy it there, then do the string conversion, then free the temporary buffer. Another way, which was used sort of earlier, was to, the compiler also supported function overloading, where you could have multiple copies of a function, and one would take the normal 32-bit Windows pointers, and the other would take 64-bit pointers. And so there was actually a fair number of these implemented for things like multi-byte to wide character and other string functions that were called commonly. We also used this to implement OpenGL, which I think needed a lot of its own kind of crazy hacks. One of the interesting ones was with GL map buffer, which maps a buffer object into the host address space. So you can access it through a pointer. Of course, that pointer is 64 bits. On the Mac, we were able to use mockvm remap, excuse me, to remap that to below 4 gigabytes. And that's actually worked okay. I don't know how happy Apple was about that, but it's worked through a few system versions. We also had a case where the X audio DLL was implemented using the Unix F audio library, which is designed to be fully compatible in terms of structs and parameters and function names. And so it would just pass these pretty complex structs straight to the Unix library. That worked fine when they were both 64 or both 32 bits, but the mismatch here would cause things to break. And so we had to add manual code to marshal the parameters out of the 64-bit struct or out of the 32 to a 64-bit struct, call F audio, and then marshal the result back. Luckily, in the last year, this has been fixed since Wine now includes the F audio source. It's built as PE, so there's no mismatch. So using the hybrid compiler, CodeWeaver's shipped crossover 19 based on Wine 4.12 in December of 2019, which included the ability to run 32-bit Windows apps on Catalina. And that came 2 months after Catalina's release, which is not pretty good. It's quite an achievement.
It was a bad.
Maybe more than 2 months. And we've continued to use the same compiler with minimal changes for the next 3 releases, 1 a year or so. And we're generally porting that Wine, the Wine diff forward as well. Now, the problem is that the Wine changes resulted in a massive diff versus upstream. Some of the changes are showed. There was changes needed in the loader that were heavy and Wine build and include files. So this was not merged upstream.
Alexander refused it. All his fault.
And one reason, among others, being that this required a forked compiler. Those changes were never upstreamed. I don't know if it was ever really even considered. It's a pretty specific solution for us. And of course, we'd like to support multiple compilers as well, not just Clang. Yeah, so like I said, minimal changes needed to the compiler. The only thing we've really had to do year to year is every year Apple may add some attributes to the macOS SDK for improving Swift bridging or something. And we just have to cherry pick some Clang patches. So, of course, this was not going upstream. Alexander talked yesterday about what the upstream solution has been, which is the PE separation process. The idea is to build as much of Wine as possible as PE DLLs. They don't have direct access to Unix APIs. If for things that do need access to Unix APIs, separate them into a Unix library, which has very limited access to Windows APIs, really just NTDLL. This creates a hard boundary between the PEDLLs and the Unix dynamic libraries, with the goal being that the PEDLL could be 32-bit, the Unix library could be 64-bit, which we now need to have on the Mac, and there's manually written thunks in between to marshal parameters back and forth. And just as sort of simple illustration, the Wine, a 64-bit Wine process, 32-bit Windows EXE, 32-bit PEDLL talking to 64-bit Unix DLL. And this allows for what we're calling WoW64. This is very similar to the solution that Windows uses, which is called WoW64, Windows on Windows 64. That's used there for running 32-bit EXEs on the 64-bit OS. This exists in upstream Wine. It's partially functional today. I think we're going to get a demo later, which is going to be great. Crossover 22, which was shipped in August, uses both WoW64 and the hybrid compiler. There's only 3 DLLs that are built with the hybrid compiler. There's just OpenGL, WineMac, and Win32U. But things are tricky because you've got the WoW64 machinery and also the hybrid compiler thunks that are both switching the processor in and out of code segments. And yeah, it was a little tricky to make that work, but it is working and shipping. And we are hoping that this will be the last release that uses the hybrid compiler. No, right? I'm hoping that too. I've spent the last 2 springs almost merging that patch into rebasing it onto a new wine. So now, of course, things couldn't be simple. After we shipped crossover 19, working on crossover 20, Apple had another announcement, which was the Mac's transition to ARM64 and custom SoCs that they call Apple Silicon. A big part of the transition was an emulator called Rosetta 2, which the translator or emulator for running existing, at this point, all 64-bit Intel Mac applications on the new Macs. It's mostly an ahead-of-time translator, but also includes a JIT for self-modifying code or JavaScript engines that generate their own code on the fly. And great news, it also supports the 32-bit code segments and was able to run Wine essentially from day one. Of course, Rosetta is not able to understand PEDLLs and translate them ahead of time, so that all gets JITted. Rosetta also works at the command line, and macOS includes all binaries on the system as fat binaries with ARM64 slices and also x86 64 slices. So I'm pretty sure that if you want to build Wine and target Intel, you still need to actually do it from an emulated command line. And just to show, you can launch a terminal, you can run an emulated shell, and then everything spawned under that will prefer to also be the emulated binary. So if you just run Clang and you compile something, it will output an Intel binary. This seems a little crazy, but it actually works really well. It's fast and pretty reliable. At CodeWeavers, we're now doing all nightly and release builds on an M1 Pro Mac Studio. So more specifically about Wine running on Rosetta 2. It needed pretty minimal changes. One thing was that in the Mac driver, the GPU detection assumed that all GPUs were going to be PCI devices. If you use IOKit and start from the GPU node and go up, it expected to find an IO PCI device. And that's not true here. It's just mapped into memory or something like that. Also, Crossover started building Wine using minus MFP math equals SSE to avoid x87 floating point instructions. This was especially important for the MinGW DLL, DLLs built with MinGW, because those were defaulting to x87. In particular, things like direct sound, which does audio mixing, that's floating point heavy and latency sensitive. See, we also needed some preloader changes that we found later on. Rosetta mapped a bunch of memory right at the 4 GB line, and we found one Microsoft DirectX redistributable that had an exe inside, and the image base was right at 4 GB, so it wouldn't load under Rosetta because the memory was taken. So we had to add a zero fill section to just force Rosetta to not allocate memory there and to just shift it up by a couple hundred megs. Also, there's a Windows function called getSystemFirmwareTable that's used to get the SMBIOS table. On Intel Macs, we implemented this by actually just getting the actual SMBIOS table from the hardware. On the ARM Macs, there's no SMBIOS table. On Linux, we have to generate one because the kernel doesn't give unprivileged users access to the SMBIOS. And So on Apple Silicon, we're also generating it now. There were some games that needed this, some game launchers, and also WineBoot uses it to populate some registry entries with the like BIOS version name and hardware model. That's stuff that's in SMBIOS. Yep. I'll get to that just in a bit. So yeah, Rosetta 2 also had some limitations. Probably the biggest one, x87 floating point performance is still currently quite slow. You know, if you consider what it was sort of designed, the original design brief and what it's designed to do, which is run existing Intel Mac applications, almost none of which use x87. Every Intel Mac ever has shipped with SSE, and of course every 64-bit processor. We're hopeful this might get improved. There are a lot of 32-bit games that may do audio processing with x87 or, you know, gameplay calculations or something. You know, anytime before about the mid-2000s, it seems pretty common. Also, floating point exceptions are not implemented. We did find an application that relied on getting a floating point exception to not crash at launch, and that's just not going to work. This is publicly reported by Apple. There's no AVX support. This has not been a problem. I don't think we've found any games that fail because AVX is missing. You know, you have to go back about 10 years to get to Macs that didn't support AVX, but there's a pretty short window where you could actually assume that every Mac had AVX, and people seem to love running games on like Core 2 quads and stuff that also don't have it. So it seems like, certainly until now, it's not something that game makers and software vendors have depended on. But that may change. Yeah, so the game would. Yeah, some could try. You know, I think they'll probably check this. Oh, sorry. Yeah, the question was if we have to report to a game that it doesn't support AVX. Yeah, I think there's multiple ways that games would check for that first. CPU ID instruction being the main one, and you know, there it reports that it's not there. A little more esoteric. Rosetta is not able to detect if code is modified from another process using mock VM write. You know, Rosetta translates like a page at a time, and that detection only happens if the memory write happens inside the process. macOS allows memory writes from different processes. We hadn't found anything that used this until recently. There are some game launchers that run some licensing code in a separate process, and they actually write a byte to the entry point to like change it. So far, found a workaround, which is just to flip the execute byte off and then back on. Also cross-process. On Wine, that's done through kernel APC. So the protection bit change happens in process, and that seems to trigger Rosetta to retranslate the page. Because otherwise, if you execute it again, it just executes the old code, essentially. Similarly, macOS allows you to get register states cross-process through thread get state. You can't retrieve the x86 register state cross-process. It'll just show the ARM register state of Rosetta, basically. And in Wine, this was done to get the debug registers. The server would read it cross-process, and that was failing. Also, the x86 debug registers are not really implemented. You can't set a breakpoint. If you read them, they're all zeros. Luckily for games, we found that that's all they really want. They just want to see that they're not being debugged. And a big limitation, Rosetta is really kind of an opaque box. It just runs the whole process. We have no logging or debugging or metrics visibility into what it's doing, which can make it hard to debug and find bugs. First, I want to say we've been able to work closely with the Rosetta team. They've been very responsive to finding our requests and our bug reports. They fixed a lot of bugs in the last 2 years. I think I counted 15 or 20 maybe. Through Big Sur and Monterey, probably every update had a fix for some bug we had reported, especially during the Big Sur timeframe. That said, finding and identifying these bugs has been a real challenge, even versus the normal world of finding troubleshooting wine bugs. Not being able to trust the CPU is pretty different. We can't boot Rosetta into Windows. Just debugging things inside wine is difficult. You know, creating small test cases is really what we had to do, and that was not always easy. Some of the crazier bugs that I have found in Rosetta through the 2 years, if we did a move from a segment selector, which is 16 bits, to memory, it would write 32 bits to memory instead of 16, which possibly overwriting data. We sort of didn't find this at first, I think because this was being used to dump registers onto the stack, onto memory. And if you write them in ascending order, then it doesn't matter that it's overwriting past its bounds. But then after a wine update, the syscall machinery changed, and we were writing them in descending order, and so every write would trash the one before it. Luckily, they fixed that pretty quickly. And my workaround temporarily was to just change them to be writing in ascending order. We've also found 2 bugs that were race conditions between signal delivery to the translated process and instructions that modified segment selectors. Wine uses signals for async I/O and other things. So we would see crashes in like Steam or Chromium. One was with popping off the stack into the DS register, and that would just, I think, crash. The other more recent, that was luckily fixed pretty quickly. And the workaround was to pop into a register and then move from the register into the segment selector. More recently, we also found a bug with long jump. We previously only used long call to do those far calls, but with the WOW64 change, it was using long jump. And we found that sometimes it would do the jump, but it wouldn't actually change the segment selector. So the processor would still be in 64-bit mode, but running 32-bit code, and it would crash in a very weird way. Luckily, not too far down the line. So overall, Rosetta's worked very well. The performance is excellent, and that probably has to do with both the silicon and the hardware and Rosetta itself. Even with the CPU being translated, we found that game performance can often be better on an M1 than on an Intel Mac with an Intel integrated GPU, just because the GPU is stronger. So that's been sort of what we've been through lately. And as for things in the future, the P separation is ongoing and close to being done. One thing we're looking forward to being able to implement is having 32-bit apps being able to use Vulcan. We never really got this working with the hybrid compiler, but it should be working now upstream. And this is good because WineD3D or DXVK will now be able to use MoltenVK for 32-bit Windows games. Until now, we've just had to do OpenGL. Also, something that's been a pain has been the conflict with the GS register. Hopefully we can be able to swap that when entering or leaving Windows code. I've spent quite a bit of time on this, and Stefan and others, so I thought I would go through some slightly gory details. Both Mac, 64-bit Intel Mac, and Windows use GS to point to thread-specific data. On macOS, they do call it thread-specific data. On Windows, it's the thread environment block. And without a hard boundary between the Windows and Unix code, they both had to share GS, and that being the macOS one. Apple actually reserved 2 pointer members in that array for our use, self and thread local storage. That's what most Windows apps directly access, so this allows most apps to work. But there are apps that do direct accesses to other members, and we've had a variety of sort of hacks for those. One is Direct3D, which is the process environment block. Most versions of the Windows 10 SDK contain some static C runtime bits that would directly access this on, I think, thread creation and exiting the process. Crossover has had a hack to make this work that's kind of ugly. It involves like hooking local time in the macOS libc. This has actually been fixed in the Windows 11, the latest release of the Windows 11 SDK. I reported it as a bug. Microsoft didn't fix it because of us. It got fixed for something unrelated, but it is now fixed if you rebuild your app against the latest SDK. Another one is 0x8, which is the stack base. Chromium pre-version 87, which is almost 2 years old now, I think, would directly access this. I landed a fix that went through one of those other reserved members to get it instead. But old versions of Chromium last forever. So we've had to, one hack we have in Crossover now is to actually do a load time binary patch of specific versions of libsef.dll. This is what got the Rockstar Games Launcher and Grand Theft Auto 4 and 5 working in Crossover. We also have one for BeamNG, which is some driving simulation that uses like Chromium 3 or something. If projects update to newer Chromium versions, that would be very helpful. We've seen some games that use 0x20, which is fiber data. We don't have a solution for that. Luckily, it's been fairly rare. And so we're hopeful that once P separation is complete, we can swap GS when entering and leaving Windows code. There's some concerns about performance because that would probably require a system call, but we still need to kind of measure that. And once we do that, then all that stuff can go away and we'll never have to think about it again. We can get rid of all these hacks. That would be fantastic. So one other thing that's kind of on the future we've thought about a little bit is running a native ARM64 Wine on macOS. There was some basic work done for this in 2020, but it hasn't gotten much attention since we've been working on all the other stuff. There are some kind of issues that pop out, obviously. One thing is that for ARM64 binaries, Apple enforces a page zero size of at least 4 gigabytes. If you try to build a binary with page zero smaller than that, the kernel just terminates it on launch. Windows stores user shared data at the same pointer in that 4 gigabyte range on all architectures. So at least today, we can't map it there. And that's hard-coded in various Wine DLLs. And I'm sure there are Windows programs that directly access things out of it as well. Pages are 16K. Windows uses 4K pages on ARM and Intel. Not sure how easy it would be to work around this. Certainly not as a fully 100% solution. In addition, Windows uses the X18 register to point to the tab. On macOS, and I think in general for the register ISA, X18 is reserved for the host OS. It doesn't appear that macOS uses it, but it's also not clear that we can sort of use it for anything we want. There's reports that iOS sort of zeroes it out on like context switches. I'm not sure if that's still true. Basic experiments, it seems to stay there when we put it there, but this hasn't been investigated deeply. You know, there's probably not a huge demand for people to run native ARM64 Windows software. So this would really be useful more as sort of the host side of a WoW64 configuration with an x86 emulator to run Intel binaries. So that is all I have. If there's any questions. Yes?
I realize that you're not using that island anymore. I'm curious if, I guess it was just too complicated to use like LLVM's plugin architecture to handle all of that. Is that what you were having before?
I would assume so. I wasn't involved in implementing it. But yeah, I think it made pretty deep changes and to the language front end and back end. Yeah, it would be interesting to know if it would be possible through a plugin, but yeah, I'm not sure. Any other questions? Oh yeah, questions if any possibility Apple would remove Rosetta. So we don't have any inside information about that. You know, I think it is probably intended as sort of a transition mechanism. Certainly it was with Rosetta 1, which was the PowerPC translator for the Intel transition. You know, there's some signs that it might stay around longer than that. Certainly they haven't made any changes in the App Store submission guidelines. You know, you can still submit an Intel app to the App Store. They're still selling Intel Macs right now, of course. And one thing, you know, this summer they announced that Rosetta is available on Linux as well, with the intention that you would use it inside a Linux VM running on an M1 Mac. I think there's maybe less of an expectation that that could sort of go away in a few years, versus on the Mac side where maybe there's more expectation that the software would get rebuilt and be native. Anyone else? Yeah.
Start translating and executing code within processes otherwise not.
Yeah, so the question is if Rosetta only emulates an entire process or if you can sort of break out of it inside that process and run ARM code. The answer is it only runs a full process. Yeah, there's no way to mix and match ARM and Intel code inside a process, which is different than how Windows is doing it now. They have options for that. Yeah.
How can we run WoW64 applications with Rosetta?
The question is, how can we run WoW64 applications with Rosetta? So you mean WoW64 being 32-bit Intel apps, or? Yeah. So we're running an Intel binary of wine, 64-bit Intel binary wine, and then it's making the same calls to set the LDT and set up 32-bit code segments and jump into it. So we're not executing any ARM code there, but we're just running the same binaries we're running on Intel.
I guess my question is, like, because you brought up at least well running, or maybe I misunderstood, but I thought it's like you could use ARM64 on the Unix side and run a TE Intel binary.
Oh, so yeah, questions about my slide about running ARM64 wine and then WoW64 on top of that. So yeah, no, with Rosetta today, that's not possible to use Rosetta in that configuration. Yeah, it just has to be a full process. Yep.
So the problem with the user shared block.
Oh, so yeah, questions about user shared data and how that works on Rosetta now. So for Intel binaries, the page zero size can be much smaller, and it really has to be because if you're going to jump into 32-bit code, it's got to be stored there. So I think Rosetta gets special permission to map, change that mapping and map code under 4 gigabytes. And it also obviously emulates, it has 4K pages, that as well. Anyone else? All right, thank you.
Okay, welcome back from lunch, everybody. Cookies are good. My name's Bill Hollings. I'm the lead developer on MoltenVK. I maintain the repository and coordinate activities there. Today I'm going to talk about MoltenVK and Vulcan portability. They're two topics, but they're highly related. I'm going to talk about the product, MoltenVK. I saw references to it a number of times in the presentations this morning, so clearly a number of you, or a few of you at least, are familiar with it. And then I'm going to talk about Vulcan portability, and then we'll talk a little bit about, and I'd like to get some feedback on future directions. Okay. My company is the Brenwell Workshop Limited, and I'll get into that as well. Now, let's see if I can figure this out. Okay. So first topic is MoltenVK. Basically, for those who don't know what MoltenVK is, it's Vulcan API over the Metal framework running on Apple products, Mac OS and iOS and tvOS. Okay, a little bit of history of MoltenVK. Brenwell's been around for a while as a consulting company. We got into the gaming industry about 12 years ago, put together a game engine based on OpenGL ES2. Well, started with one, but then migrated to two about 12 years ago, 11 years ago. Written in Objective-C, it was targeted for iOS. That's the reason we got into the game business, because we were interested in producing an iOS game back when iOS was brand spanking new. Then Apple introduced Metal in 2014, and we started getting requests on our game engine, when are you guys going to support Metal? And looking at the back end, very tightly coupled to OpenGL ES2. It was also connected to a third-party product called Cocos 2D, so we didn't have complete control over everything. You guys can hear me okay? Okay, sorry, I thought you were waving to me. So we took the approach of saying, well, rather than write a different backend, why don't we just throw a layer in underneath that translates OpenGL ES2 calls into Metal. So very similar to what Angle did before that, but a similar kind of thing, but this time on Metal. Then very soon, shortly after that, Vulcan was introduced, and it was just very clear that we should also support this new fancy backend as well, or using similar kind of constructs, but basically taking the experience we had in developing MoltenGL and rolling it into supporting Vulcan on top of Metal. MoltenGL still exists. It's sold as a licensed product. Since Apple sunsetted, sorry for the since Apple sunsetted OpenGL on its products, there's been quite a bit of interest from game developers who are interested in maintaining their existing OpenGL games. And as you guys know, old habits die hard, so OpenGL is still going to be around for a while, even though Apple is not really supporting it very well anymore. That engine was written in Objective-C. When we moved over to supporting Vulcan, we rewrote or built the engine for MoltenVK on C++, because that is with Vulcan being a C-based API, and games are typically built in C++. We decided to focus on that. That was actually a good decision. Moving forward a couple of years, Valve got very interested in MoltenVK and started funding some development. So we worked for a couple of years with Valve on enhancing MoltenVK, using it to underlie a couple of games there. And then we got into discussions about the benefits of open sourcing. So Valve got interested in not only the product, but also in open sourcing the product. So they funded transferring MoltenVK from a licensed product, which it was before then, to an open source product. That was released under Kronos. So Kronos has been supporting MoltenVK from a function, not from a publicity and industry perspective as well since then. So right now, or since 2018, MoltenVK is an open source product under Kronos. It's under the GitHub is under the Kronos group environment on GitHub. Codeweavers also got interested in it about the same time, a little later on in 2018, and started in some of the porting that they were doing, started contributing quite a bit of code to the MoltenVK repository. So that's a little bit of the history. Here's kind of this is a really messy, complicated slide, but it just sort of shows, again, a little bit of the history from that June sort of introduction. Codeweavers getting involved a little later in there. Valve, we released Dota 2. A little later on, Valve also did an iOS game, and then there's been a number of developers interested and involved in this. Okay, so the current status of MoltenVK is it supports Vulcan 1.2 right now. That was just actually came out in the last couple of weeks. So we're now up to 1.2 plus a number of extensions. It's embedded in the macOS Vulcan SDK that LunarG puts out. It's a key component of the Vulcan portability initiative. So actually MoltenVK really catalyzed the concept of how do we support Vulcan on platforms where the underlying platform isn't able to be conformant with like full-blown Vulcan. And so the Vulcan Portability Initiative, which I'll talk a little bit more about in a minute, was created to figure out ways to support the industry in having Vulcan in environments like Metal or other platforms where it wasn't possible to become completely Vulcan conformant. In that vein, we're currently undergoing an extensive ongoing activities to reduce CTS failures. For those of you who don't know, CTS is Kronos's Vulcan and OpenGL test suite. There's about a little over 1 million CTS tests for Vulcan. And basically to be conformant, you have to have 0 failures. On not necessarily on all 1 million, but all of the whatever proportion of that you are supposed to support. Okay, so ideally we want to get down to 0. That's not actually possible because Metal doesn't support all of the functionality that Vulcan needs. So it's never going to be possible to get to 0. So the Vulcan Portability Initiative is a mechanism that we use to define sort of a second tier of conformance, and I'll get into that a little bit more later on. Other improvements come from bug reports and enhancement requests that you all put out on the Vulcan GitHub, the MoltenVK, GitHub repository. So keep those coming. There are definitely some stuff here, and I'll talk about that towards the end. The graph on the right is from Karen. They do a regular poll of people in the industry, and this is a couple of years old, but it's showing that, as we all know, by far and away, desktop Windows is the lead in terms of developer interest. But the combination of Mac OS and iOS is actually still pretty significant. So a lot of developers, game developers, are viewing Mac and iOS as an important platform to be able to support. Okay, I'll talk about a little bit about the Vulcan Portability Initiative. Here's an incredibly dense slide. What it's doing is it sort of summarizes the state of layering. So the left hand is, sorry, the right hand is the API, right hand, the top dimension where we go Vulkan, OpenGL, etc. Horizontally. That indicates the platform that I want to start from. That's the API that I want to use to write my game. And then following that big red arrow on the left, the platform that I'm going to actually support it on is on the left. So you can see MoltenVK is down in the bottom there, going from Vulkan to Metal. We also have OpenGL ES there, MoltenGL, and Angle going from OpenGL to Metal. Angle also obviously goes from OpenGL to OpenGL ES to OpenGL. A lot of you are familiar with the top right there, going from DX12 or DX9 to Vulkan. A couple of presentations this morning about that. And surprisingly, there's some interesting ones. There's Zinc, which goes from OpenGL to Vulkan. There's, where is it? Going from Vulkan to, Ashes. Yeah, Ashes going from Vulkan to OpenGL, which is even a more bizarre concept than going from Vulkan to Metal. So this is kind of a summary. There's a lot of activity going on in the industry with regards to, platform viability and platform support, cross-platform support. The portability subset extension is a product of that portability initiative that I was talking about, or that I am talking about. And the idea here is to identify where a platform will be non-conformant. So for instance, Metal does not support triangle fans. So if you're using triangle fans in your game, it's going to break. And we identify that by having an extension that has a structure, and in that structure it has a series of flags. So it's very similar to the Vulkan feature flags, but they're actually reverse flags. They're actually flags that indicate we don't support this, we don't support this, we don't support that. So right now there's about a dozen flags. That list is kind of growing because as we crank away at reducing the CTS, we find the CTS tests failures. We find when we find, we cannot pass this test no matter what magic we do in MoltenVK or Spear vCross or anything like that. We cannot do it because Metal doesn't support it. Then we add a flag to that structure. And once we get those tests down to 0, we'll have a definitive set of flags that say, if you're running Vulkan 1.0 or 1.1, here are the things that you may or may not be able to support on any particular platform. Okay, sometimes they do, sometimes they don't. It depends on, and so for instance, depending on how far you go back on iOS or Mac OS, sometimes you're going to support it, sometimes you're not. And it depends on the GPU as well, obviously. Okay, so that's a way of allowing a game or an app to query what are the actual capabilities of this non-conformant platform in order to, that I know it will be conformant on, at least. Okay, now I want to talk about the future. We get requests both from DXVK and VK3D to add features. So here's a current list of requests that we have to add extensions in this case. Some of them are possible, some of them are not. There's quite a bit of talk about memory mapping earlier, which I'm very interested in. So this is the current list of requests from DXVK, and for those of you who are working in that environment, by all means, please add to the list. There's an issue specifically for DXVK requests. And similarly for VK-D3D, there is a set of requests coming as well. So these once again are, please support these Vulkan extensions because we need them for various games that we're working on. Okay, and again, there's an issue on MoltenVK. So if you're working on a port or developing a game and you're finding it's not working here, then by all means, say, oh, I need you to support this extension, or this extension's broken, or whatever. And finally, we got a bunch of requests about Metal 3, so I thought I'd just say a few words about Metal 3. Metal 3, it's a significant extension. One thing it critically added was buffer device address, so we can now do things like support the buffer device address extension, so you can pass pointers into the shaders. Also, there's related to that is a redefinition of how they handle metal argument buffers, and that is going to allow us to improve our behavior of indexing support, descriptor indexing support. They introduced mesh shaders and enhanced ray tracing. I didn't write that down, but I should. Apple recommends that geometry shaders and faster tessellation shaders can be accomplished by using mesh shaders, if the platform supports mesh shaders, obviously. So their strategy there is to just say, look, mesh shaders are the future. So rather than provide specifically geometry shader support, we're going to provide you with mesh shaders, and so it would be up to us to munge that into effective geometry shader support. Tessellation shaders, for those of you who do use those, you'll have probably noticed that they don't perform particularly well in MoltenVK, and the reason for that is because the way that Metal does tessellation shaders is sufficiently different than the way Vulcan does it, and the impedance mismatch there causes a fair bit of switching between compute shaders and rendering shaders. Okay, and I believe that is the end of my presentation, yes. So that's where we are. That's sort of a history, the relationship between MoltenVK and the Vulcan Portability Initiative, and a little bit about where we want to go with support for D3D activities. So I'm very interested to get feedback. You can either talk to me directly, or my brain is, I'm not going on a lot of sleep right now. So rather than rely on me to remember things, please by all means contact me, contribute to the issue list on MoltenVK if you've got specific things you want to discuss. But I can take some questions now. If anybody's got anything.
I know if Apple wanted to help MoltenVK, there are a lot of low-hanging fruit that they would have. For example, triangle fans, I believe, are supported in all hardware. They're not giving you the header off of that. Do we know? Is that something that's going to change in the future?
So so triangle fans in particular, clearly they. Oh, I'm sorry. If I can summarize, what's the support from Apple for activities that we're doing? We do have a relationship with Apple. It is, as we all do, they are interested in being competitive. So they are interested in what Vulcan is doing. That's not to say they're committed to stay even. Clearly something like triangle fans, yeah. OpenGL now runs on top of Metal. So clearly Metal can support triangle fans at some, or maybe the driver's doing a copy, I don't know. But yeah, it's not publicly available. Apple is very proprietary, as we all know. They are interested and will dialogue, but and we can certainly file as many radars and requests and things like that, but they steer their own ship. So it's not, I can't say they're going to be, extremely responsive. They want to know, like, for instance, the introducing mesh shaders. Oh, surprisingly, it came out, just after mesh shaders were introduced everywhere else. So they're interested in being macro level, not compatible, competitive. Because they've got, people like Unreal and Valve and whatever, hammering them, saying, if you want us to write games for your platform, we need these features. They're not necessarily going to say, oh, well, let's make it exactly compatible with Vulkan, right? That's not there, because they've got their own, their own marketing spin on that. So yes, so the summary there is, yes, there is interest, but not commitment. Yeah, right now, sorry, the question was, are there other platforms that Vulcan portability would be helpful for? Yes, Android is an obvious one. Android is kind of sits in the middle, where they're trying to be conformant but not entirely conformant with Vulcan, and there's some exceptions there. They're closer because they've got control of the drivers and things like that. But that would be an example of potentially doing that. There's also, down the road consoles or something like that, where potentially there's a inability to be fully conformant. I think once we get this going, it's possible that it creates there are just other things that come out that maybe this Windows machine or this GPU or whatever that could apply as well. Does that mean a fragmentation? Potentially, but at least it's an open fragmentation. It's saying, hey, we're telling you where we are, where we can't be conformant here. We're upfront about it. You can query it in an API and adjust your code path accordingly. But right now, yeah, MoltenVK is really sort of 99% of what's happening on the portability initiative. I'll give the back a turn. I'm sorry, I couldn't hear the question.
I'm in contact with the people who reverse engineer the Apple driver, graphics drivers.
Am I in contact with the Metal graphics developers, you mean?
The group apparently.
Oh, okay. So reverse engineering for what? So the answer is no, I'm not in contact with them. Which initiative would you? Okay, there. Okay. You're in contact. What are you doing with it?
Writing an extract for the Apple GPU. Oh, sorry, I crawled in from XPC over there. I don't use Wine.
Okay. So writing a Linux driver for the Apple GPU. Okay. So, well, nice that we're dialoguing now. Yeah. That's an interesting initiative. Yeah, if there's I'm just trying to think where there'd be overlap there, but yeah, I mean, it's definitely worth at least dialoguing about what's going on with Metal.
I guess the two angles which I'm thinking about. One is realizing that all of the GPUs supported by Metal, Apple's Intel and AMD, support tiles of feature that Metal is not supporting, and that Apple is using on their version of MoltenVK. And on one hand, if those would help MoltenVK get closer to real performance instead of portability initiative performance, I would write the patch for that. On the other hand, I realize that would mean that Apple will want people shipping MoltenVK on certainly the iOS App Store, and there's politics there.
Yep.
Native Vulcan drivers on Apple platforms. Certainly they can be made to work. I don't know if people would want them.
Yeah. Do you think you could get down to a native Vulcan driver on an Apple platform? Yeah. So, so we have been very religious on MoltenVK about not using private APIs. Mac OS, it would be feasible. Not possible at all on iOS. One of the things when you submit an app to the App Store, one of the first things it checks is, are you using private APIs? We actually got, a couple of years ago, we got hit with that because we were using an API that was public now, but if you go back a generation on iOS, it was private, even though it was the same footprint. And so people were getting rejected, like because they said, oh, we also support, say, whatever it was, iOS 10, their apps were getting rejected, where somebody who said, oh, I only support back as far as iOS 11, they weren't getting rejected because it was now a public API. So we got hit with, so we know for sure that Apple is very diligent about not allowing that on the iOS environment. However, Mac obviously is a little more free range, and so it's potentially something we could consider. We've actually had requests for that. We resist it because, you know, we don't necessarily want to create fragmentation, and the environments for them are generally kind of low key. You're not going to get, you know, huge chunks of behavior, maybe a little bit more conformance. That's about it. But I'd be interested in having a dialogue, so let's swap some contact information.
What are your barriers, or put another way, what would help you go faster other than Apple?
You mean the code going faster, or you mean development going faster? Well, manpower or person power. Right now, I'm doing almost all of the MoltenVK development. I'm the only one that's sort of dedicated to it. There are contributors. You guys were contributing substantially over the last couple of years, as I pointed out there. Also, game developers, users will contribute code in bits and pieces. So extra resources would definitely be allow us. So we're currently at 1.2, Vulcan 1.2. The industry is at 1.3. There's about a 2-year lag there. 1.3 is a big chunk of work. We're gonna, you know, obviously we keep at it. Yeah, we're always going to lag. I'd like to be in a position where we could actually have the Apple platform still under the portability initiative, but being able to contribute to the Vulcan as it's evolving, and not always just playing catch up. So having you know, some extra resources would allow us to get there.
Distracted by things like ARM processors and 32.
Yeah. Okay, that sounds good. Yeah, no, I was amazed with the presentation just before lunch, because yeah, there's a lot of messiness there, and that's an example of, you know, Apple basically going its own way, and we've all got to double our efforts to catch up. And yeah, that's a hard nut to crack. So I totally understand that, especially with introduction of Apple Silicon. That's definitely puts us all a little further behind the complexity wagon. Yep.
So, one of the things is like spirit process to translate to middle.
So Spear v Cross, yeah, there's performance overhead because you're going from Spear v to metal shading language at a source code level, and then you're going to a compilation phase. So there's definitely, it's more expensive than just going straight from Spear v to you know, native shaders. So it affects your pipeline creation time. There's a number of initiatives going on right now in Vulcan to shorten pipelines in general, cache them, pipeline library extensions that we are aiming to support as best we can, to try to make it easier to link together Vulcan libraries. So that you're still going to get hit with that exchange, but the idea is there at least you've got it more under control. So we are not doing any specific magic. We do support pipeline caches. Right now it's at a source code level. So for instance, if you save a pipeline cache in MoltenVK right now, what it spits out is MSL code. So you avoid that Spear v to MSL translation next time you load the pipeline in. And but when they've now introduced binary archives, so we're exploring how to we'll rewrite that so you can actually spit the whole pipeline out from a caching perspective, and on the pipeline creation side, where you can again use this concept of pipeline libraries, create one for the vertex stage, one for the fragment stage, and then mush them together when you need them. We're exploring that right now. So that's actually one of the extensions that we're working on right now. Again, there's impedance there because Apple, they have a different set of requirements for supporting that. So we're trying to, jimmy square peg into a round hole to a certain extent, but we're still exploring that. In terms of performance of the shader itself, it's pretty good. There's there's a lot of impedance there in terms of syntax, but Apple's compiler is pretty good. So once you do, they'll take out a lot of stuff that is overhead in the translation. So the actual shaders do pretty well in terms of runtime performance. Okay, any other questions? Okay, so thank you very much for listening to me. And if I encourage anybody who's working in this segment of the industry and using MoltenVK on the D3D stuff in particular, I'm actually very grateful you invited me along here, because it's nice to get sort of a lot more context around this, and I would love to be able to be more responsive in terms of, hey, there's this actual real thrust around D3D support. There's a bunch of Vulcan extensions that we could potentially implement that would help that along. So anything that comes up, please by all means put it on the issues list. And we'll try to get a real solid focus around the whole D3D stuff. That's a big part of our whole industry. Okay, thanks a lot.
All right. Make sure I have distance. Hi, everyone. Hi, my name is Buck DeFore. I am the creator of ProtonDB, and this is the first time I've spoken about the experience of creating a community for Linux gaming, in my personal experience. I want to first begin by really thanking Jeremy bringing me out. I know that this is there's a lot of good talks happening during this conference. Is also at the very tail end of the conference, so we're all at the very end of this, and there's many other talks that are competing for your attention. I'm intentionally not having slides because I want to speak as candidly as I can, but I will also signal that to you, I am not going to give you the kind of technical depth that many other talks will give you at this conference. What I'm intending to do with this talk is give you my experience as someone who, from a bit of the outside, from the community that we have here, what that experience is like to try to be a part of it. The first thing that I really want to do, and I've been hit or miss. I missed a bit of this morning. I really do want to start this talk with some recognition for the people that can't be here today, the people that we've lost, the people that have actually both contributed to this movement that's going on, and also to yourselves. This is something that many of us in this room are doing it out of sacrifice, one way or another, and some of you have lost people. I want to recognize that and take a brief moment just to ask yourselves to love yourselves and the people that you care about. Just take a small moment for that, please. ProtonDB is a website where, from the very beginning, was the idea about it was democratic. The idea that people don't need to have an authoritative answer about whether a game works or doesn't work. There's a lot of heroic effort going on in all kinds of aspects about making games work on Linux. And I want to recognize that so much of that is actually above and beyond what my understanding is. But there is still the possibility to create something that helps push that movement forward. And that was the moment that happened to me. I think it was August, I'm a little bit audibling here, August, I think it was 18th of 2018, when Valve announced that Proton was something that they had enough belief in to publicly announce that they would do a support of wine to create a gaming focused fork, not a fork of wine, a extended downstream of wine, as I know those words matter. And I think that moment was something that affected me deeply. I remember that morning when I was supposed to be doing work for my day job, and it struck me, I don't want to work right now because this is important. I imagine that many of you in the room felt that moment that day. And what I did that day was I made a Reddit post, I made a Google spreadsheet of the few games that were available to me that I could try at the moment, and I gave thumbs up and thumbs down effectively, or I think it was different kinds of spreadsheet text cells, kind of explanations of whether a game would work or not. And when I actually went back to work, continued being a dutiful employee, at the end of the day, I came back, there was over 1,000 rows. And what was significant to me about that was not only that I had kind of like kicked that thing off, but also that there was such a hunger. And I think that was actually already happening. I just didn't know about it. And there was a very important moment to bring awareness about this thing. So that spreadsheet, as maybe many of you know, quickly became untenable, right? It became a public spreadsheet with, I think at the end of it was over 30,000 rows of contributions from people who were interested to let everyone else know this game worked or this game didn't work, or these are the things that you could do, comments that went ridiculous levels, all kinds of, let's say, subjective differences about what was working and what wasn't working. And there was actually already something that existed before that. There was the app HQ, AppDB on that had been built by the members of the wine community, but it was built for a different time. It was built to try to understand native games, how well they performed on Linux, and there was a rating system around that, right?
I was talking about something else.
I may be actually conflating a few things, but what was important though was that the experience that anyone had on a game would be really dependent on a number of factors. That could be their distro, that could be their graphics card, that could be the drivers that they've installed, a number of factors. I'm very appreciative of Valve for making the choice to have that flag that was to opt in to being able to run things that were not whitelisted to be able to be run, because that enabled this entire community to explode. And what I want to talk about today, and again, I'm not going to get into a lot of technical detail. I'm happy to get into ProtonDB's technical implementations, but that's not the main focus of what I want to speak to you about today. What I want to speak about is the power of one. The idea that that day when it hits you, that thing that can hit you, and do I actually set aside some time to do something that might add up to something? It can really work. And it comes from something that I'm pretty sure that you've heard some talks this entire conference about very important duties that you can do to make merge requests that matter and be very calculated, be thoughtful and considerate about your reviewers and the community generally. I'm going to talk about something a little bit different, which is forget all of that. Think about if it matters enough to you in that moment, like the way it hit me on August 18th, 2018, is there another moment that's about to happen that you could, anybody in this room right now could be someone that, how can I help move that movement forward? I really want you to think about that out of my talk, if anything, because ProtonDB is an example of that. It is a flawed, crudely designed, hacked together job, but it had an impact. And I think that anyone in this room has the varying skill sets to be able to do something like this again. ProtonDB is, at this point, over 200,000 reports. It's not something that's shown on the website anymore since the redesign, but it is something that from its very beginning was meant to challenge the idea that what is the canonical version of does the game work? Is it verified? And credit to Steam and Valve to have the idea of having an answer to, is this verified? But there is also the answer to, or the interesting question around the idea, does it kind of work? Is it all right? Like if you tinker with it, is it going to be worth the effort? And then the excitement that comes from people who care enough about a particular game to make that work with a little bit of work. I think that that's something that is at the ethos of what this whole thing that drives us to be here today. I think that ProtonDB is a crude, cobbled together thing that I was able to put together in my spare time that many of us could do in an answer to a kind of question that we are about to encounter. I think that in my particular skill set, I am a web engineer, I specialize in web technologies. I think that there's actual like ways that you can answer that question differently based on whatever skill set you currently have. And it doesn't have to follow the format of what Hugh had gracefully talked about how to best contribute into merging into the wine community and contributing in that actual technical way. But there is actually a moment that might hit you where like, hey, do I do a social media post? Do I open up a public spreadsheet? Do I do something that actually helps this thing move? To come back to the spreadsheet, it quickly got unmanageable. As I think many of you have talked to me in this room, it got to over 30,000 rows, and it quickly challenged the idea that Google Docs actually had made a functioning piece of software. Now, excuse me if I may actually lose my voice a little bit because it's rare that I actually have to talk for a long period of time. But there was a heroic effort from I think maybe even some people in the room to help get that data into something that was useful. And I still had a day job. I still had to actually keep my sanity together as I, made an income, but also cared enough about what was happening to help shine a light on something. And for the first month or so, that was something that I did in the evenings. And then my contract of the work that I was doing expired. And so I intentionally let it go because it was getting very exciting. And then there was a period of a month, Pierre-Loup, I respect the fact that you allowed me to use ProtonDB.com as a name, although it's allowed for a certain amount of confusion about whether it's Valve sponsored or not. It's not. It's actually just a human effort of an individual or potentially a group of individuals that care about this a lot. But thank you for that. I should have actually, instead of calling you out right now, I should have let you know. That mattered because people were looking about what is this thing called Proton. And I also recognized that the wine developers have actually done a lot of work to actually do that behind the scenes before it was sort of christened as something called Proton. Wine is actually something that's been slowly growing over, 25, 30 years now? Yeah, we have done something, folks. It's really amazing. And it will go in sort of fits and starts as far as its applicability to how it affects people, whether it's gaming or whether it's you might be able to legitimately get your computer to start up on Linux instead of Windows by default. I really want us to think about what are the moments that we can create a movement or create a sort of like a side of the movement that is something like ProtonDB. Because humbly speaking, I really think that what I created was from a web engineer kind of perspective, it's a CRUD application. It allows people to write reports in a kind of democratic kind of way that doesn't authoritatively tell you whether a game works, but it gives you some hints about whether it's something that might work. And that is enough in and of itself. We've gone from 2018 to 2022 where Valve has legitimately put their effort towards making a hardware version of this ideal, the Steam Deck. It's not necessarily what people have aspired to on their desktop, but it is a portable console that is something that is this idealization of all of this effort that we've fought for in this room. I don't want to speak about a lot of the technical good details that people have come up with at this conference. I'm glad that I've been invited. Thank you, Jeremy, because I want to speak about how it's actually very possible for us to be a part of that multiplier about what that could look like and how we can actually individually accelerate that. I've suffered somewhat from ProtonDB's escalation because it's a lot bigger than I had time to dedicate to. I've juggled that with my personal jobs. I've juggled that with my sanity, honestly, and dealing with feedback that sometimes made me want to quit it. But it was always in the direction of something that the majority, if I believed in what the mission was, something that I deeply cared about. My screen keeps cutting out, sorry. I really want us to think about things beyond ProtonDB and think about the power of one. That's why I've titled the talk in this particular way. Everything that you are doing, yes, there are sort of unrecognized efforts that are these sort of invisible things that make wine work better, but there are also the things that help people understand that we've already reached this moment. We don't need to talk about Linux on the desktop anymore. We just need to talk about, does this solve your problem? Does this actually get you what you want? And that was always the motivator for me. I'm a bit of an outsider. I first played with Linux in 2004 with Slackware, and I quickly learned that there's a difference between how Windows thinks about moving folders versus how Linux thinks about moving folders, and I lost a bunch of college photos. But that is part of my journey, right? There's danger in some of these things, right? But I think that the important thing is that there's a big difference between 2004 and Slackware and what we have today. I really want to recognize all of the effort that the people who are committed enough to be here today about why that's important. I also want to recognize that that what I've done has gotten beyond my capability to really maintain. There is a rating system on ProtonDB, which has gold medals, platinum, gold, silver, bronze, which was born out of a good intention of the wine designation, particularly around native support. But we're living in a different age in a way, right? There is the ability to tinker. There's tools that are available to consumers to be able to make small changes and make them work, or more significant changes. And the rating system on ProtonDB, I embarrassingly will say, is just really giving a bad information about what that experience might be like for people. Some games, if you are dedicated enough, will end up being platinum or gold, and it will not necessarily signal to you what effort it might be required to actually make that game work well, or to a significant enough way that you enjoy it. I think that that's okay. That's a natural effect of me to be humble about this, the effort that I've been able to cobble together over this time to make something that still moves that movement forward, while maybe sometimes affecting us in a less accurate image than I would like us to look at. But it is still something. And I think that it is really enjoyable to be here in this moment, to recognize that there's things that I can do to improve it when I can find time for it, or when I can fit in my life the way that a website is a part of this movement. But it is also something that I recognize it's more than me. And I really want to thank everyone who is doing all this work to help this move. I'm really just kind of like putting a face on it of some kind. If there is a way that I can improve it, if there's a way that I could be funded for some way to try to move it forward, that is something that we could talk about. But I really think that this is an example of something that I want everyone in the room to feel like you could do something like this. There's more that I wanted to get into the talk, but I recognize that in the limit that we have, there's bound to be a lot of questions, because this is the first time I've publicly spoken about this website that I've created, and there are things that will come up. So I'll stop at that point, and please ask questions if you have them.
So I'm curious, and so first of all, thank you for all that you've done, because I think we all watched with fascination as that spreadsheet took off and accelerated. I'm curious to hear the story of those days where it went from the spreadsheet to the database, because it was fast, if I remember it right.
It was fast, and to restate what Jeremy is saying, there was this moment where things were moving very quickly. I believe it was from August through September that I continued doing my job, and then I finished that job, and then through the month of October was the big push to create actual ProtonDB.com. But there's many ways to get to the end of the line, right? That can happen quickly or that can happen slowly. But yes, that moment was this really powerful thing where there was a lot of feedback. There was a Discord channel that popped up. I don't actually know the people involved in creating the Discord channel for ProtonDB, for example. But some of them have been really influential. For example, I want to call out Nox Phasma, who is a human being in Germany, as far as I know, that I really want to tip my hat to, because he has, for the last 4 years, been on that Discord channel and answering all kinds of questions, and giving me, honestly, some cover for things that I'm not actively working on. But in that brief period of moment in the very beginning, it was a lot of chaos, honestly. I had to juggle a lot with my life. I had to juggle a lot with what do I do when I make a decision about taking a contract in web engineering stuff, or do something that I actually care about. How do you put a price on that? It's never been something that I've been able to actually resolve in my own head. But it is something that I'm very glad, like if I look back at a number of, like maybe the last decade of software engineering that I've done, this has been the thing that I'm the most proud of. Yes.
As someone who's looked at a lot of user reports, it's amazing to me how much each report has all the information that I need, and like the quality, and like the selection of what you chose to be on the side as the details that everyone needs to know about is like the details that I need.
I'm really glad to hear that. And Anna, right?
Yeah.
From Codeweavers has mentioned how this has been very valuable for her to try to understand and diagnose issues that might be happening with wine. So if you're listening to this talk online and you're thinking about, does it matter that I'm writing these reports? There's your confirmation. There are people who are actually using this as a resource. Fortunately, some choices that we made about, and also Steam being able to export your system data in a parsable way that was really helpful for me to sort of bootstrap this website. So it does feel a little bit hacky the way that Steam did that, but it was actually this sort of hidden key to bootstrap this movement, at least as far as reporting things. I would also, I'm a little bit of a tangent, but there was a whitelisting program that Valve had released simultaneously with Proton, and that had its challenges, right? Because it's difficult in 2018 to be able to say this game is verified to run properly. At that point in time, the technology just wasn't really there to have a predictable experience for a non-savvy user to be able to enjoy or not. And so that's partly why when I designed this, it was to put some system information to not only help the casual user look at, okay, this is happening on only AMD graphics cards or NVIDIA graphics cards, but potentially with this particular driver version or with this particular Proton version, right? That was helpful not only for users who are trying to fix these things on their own machines, but also to Codeweavers and also to Valve. There was this symbiotic thing going on, right? Yeah, please.
I just want to say, sorry, part of that.
I'm sorry.
If you have any advice about like how you chose the things that you chose, or like how you encourage people, like if you have any advice about how to get better user feedback, that's like really valuable.
In particular for, so you were asking about, is there a way that you can provide feedback?
If you had anything like when you were designing and deciding what information to put in.
Right.
Like if you have any advice for like how you came to the conclusion that led to such a successful outcome.
Yes, so thank you for bringing that up because there's a whole swath of things that I skipped on this talk that that I think are a bit controversial and something that is in my software philosophy that I think is very important. It's something that you guys can take it or leave it as you like. I'm very critical about being like determining what is the scope that's necessary to achieve the goal. So, for example, if you identify something that I can help get this movement moving faster, ask yourself, what is the smallest thing that I can do? I know we've all heard about MVP in engineering context and how that might even be used against us, but it is actually a very important concept. The minimum viable product is a good idea that sometimes can be weaponized, but it is also something that's really crucial to getting something over the line where people can use. I want to come back to you to answer your question though and say that feedback in that moment at the very beginning, I intentionally made a decision not to have, for example, a GitHub issues or a bug tracker because I recognize that if I come back from work and I'm overwhelmed with a bunch of issues that discourage me from continuing on this project, that I might stop working on it, right? There was an intentional filter that was going on by having a Discord channel where people, if they cared enough, they could talk to me. They could reach out. I'm not hiding. I'm kind of pseudo anonymous, I suppose. But I was there and I responded very, very quickly on that Discord channel. Now, flash forward 4 years, I'm a little bit overwhelmed with Discord in general, to be honest. But at that particular moment, that was my bug tracker. That was my ability to have a connection with what mattered and what didn't. And it was really crucial, the people who were involved in August and September and October of 2018, directing what was important to them. I felt like I had something to move on and it didn't feel like work. I wasn't just looking at Bugzilla. I wasn't just feeling like, oh, I've got 20 things to do today. It felt like this is what's important. And it was such a motivating factor. Yes. The question is about page views. This has been, yeah, this has been, there's an interesting downtick going on, which when the Steam Deck launch happened, for example, we hit a peak of about 450,000 monthly uniques. I'm sorry, 450,000 monthly uniques. I can talk a little bit about technical details as well. For example, just at a very high level, ProtonDB functions as it's powered by a CDN. It's a very single page app React application. It is there are providers such as Netlify who powers ProtonDB currently that are very frugal. I've worked for companies that spend millions of dollars to do less traffic than what ProtonDB does. I pay about $40 a month to host all of it. And that is fortunately because of the architecture and the structure about what it is, but it is currently getting about 400,000 monthly uniques.
More questions? You're going to be around so people can
Yes,
talk to you or find you.
as you like.
I would personally have to say your work was incredibly powerful for me, and I know for many other people, and so thank you.
Thank you.
Can I have your attention? Hello everyone, my name is Jacek Czeban. I've been lately working on converting wine display drivers to new PE code. And we had lately, over last, I guess, years, a lot of talks about 32 and 64. In particular, we had two presentations at the WineConf from Alexandra and Brendan, who explained a lot of big technical details behind it, so I'm not going to repeat that. But it seems like it's a thing that everyone talks about, but no one's seen it working so far. So I'm here to change that. I will show a few examples of running applications. Don't expect any fireworks. It's like applications you have probably seen working, some of them already. It's just right now we don't need 32-lib libraries to do that. So to get that working, I will use a branch. It's that I have in my public repo on GitLab. So if anyone is interested in trying it yourself, I would encourage you to go and try this one. It's relatively small branch. It's about 20 commits on top of recent wine. Those commits are in decent shape. The main reason we can't merge it yet is because we first need to fix printers. If we merged it today, we would just break the printer support, but other than that, they should be mostly fine. I will do the presentation on my Mac, but it just works just as well on Linux, actually. I do most of my development on Linux, so it's not like Mac specific or something at this point. So the first thing I wanted to show is actually the first non-trivial application that I got working while I was working on this. You may be familiar with this one. And as you can see, it's running on well, 64. So another one is Wine Classic. I guess it's been used quite a lot of times to demo wine. So it's Node++, 32 bits. No, it's 32 bits, as you can see. So, yeah. So another one is a bit more complex. I needed just a small cheat to get this running. Yeah, but is it hanging? It's just slow. So yeah, those are a few applications, but I guess people are even more interested in games. So here we have one. No, it's a 32-bit build of that. So yeah, right now I can't really show you some more impressive games, mostly because Vulcan and OpenGL still need more work. I hope to get Vulcan working relatively soon. I'm actively working on that. So yeah, hopefully soon. OpenGL will be more tricky, but we'll get there eventually. Oh, I didn't. So apparently Remy sent some patches for OpenGL, so maybe sooner than expected. I didn't see that yet. So anyway, that's all I had to show you. So if there are any questions, yes.
So like, how long did this take you? It depended on the PE conversion, right?
So the question was, how long did it take? Not really me, us. It was a larger effort. I think we started conversion like 4 years ago.
Yeah, about 4 years.
About 4 years ago. So the 3260 for low-level part was implemented by Alexandra last year. So since last year, it was kind of possible to run something in this mode. Getting display drivers was another year, so I upstreamed that, I think, in August this year. And yeah, we are still not done, but. Any other questions? All right, so thank you.
Wow.